I am ready, no problem.
Okay, sir. Okay.
Hello.
Hello. Yes.
Yeah. Good morning, sir. Dinesh, sir.
Good morning to all of you.
Sir, my Sanjeev from Faridabad, sir.
Oh, very good. Acha. Very good, Sanjeev.
Yeah, very good morning, sir. I'm very keen to attend your lecture.
No problem.
Thanks a lot, sir.
Nice to meet you.
So let us start, sir. Sanjeev, sir, you please switch off your mic, please.
Yeah, sure, sir.
Okay. So we have Professor Dinesh Kumar with us from IIT Roorkee, and participants. A very good morning to all of you. So Professor Dinesh Kumar is going to deliver his talk on reliability and maintenance in industry. And so Dinesh, sir, it is over to you. You can start.
Start?
Yes, sir.
Dilwal sir, please mute. Dilwal sir, mute your mic, please.
Okay. I'm trying.
Screen visible?
Yes, sir. It is visible, sir.
Okay. Should I start?
Yes, sir. Please.
You can.
Okay.
Good morning. Start, sir.
Good morning to all of you. Today's topic is reliability and maintenance in sustainable manufacturing. It's very important topic because without the reliability concept and the maintenance in the industry, we cannot achieve the target. So reliability, we have seen many times if the system is not reliable, then how it can be disaster. You can say can create the disaster. And many incidents we have observed many times that because of the unreliability factors or some problems in the component or the equipment, the heavy loss may be there. Okay. So basically, we say the reliability is another meaning of the reliability is the trust. How much you can trust on the system or the equipment. That is the main factor. Or we say the reliability will help to make the brand value. Brand build-up is the main factor which help which will be covered by the reliability. So if you say the component is reliable, the product is reliable, the machine is reliable, means you can trust on the machine, on the component, on the product that it will work, it will give you a desired function or for which it has been produced, it will give. So the main themes which will, or main idea, main concept which will cover during the talk are concept of reliability, availability and maintainability. What is reliability engineering? What are the reliability plans and the requirement, prediction, improvement, modeling, software reliability, reliability evaluation, maintenance concept, maintenance in industry, and RCM, reliability centered maintenance. So first we'll give what is the definition of reliability. With the definition of the reliability, all you say you'll be able to understand how it is important in the industry. We say a simple definition is the probability of a device or equipment or the system to perform its intended function during its life period under the specified conditions. So here four factors has been returned. Device is expressed as a probability, adequate performance, duration, and operating condition. These are the 4 things which are to be maintained in the industry or for the equipment to achieve the required performance. So we give the definition, the product or the device fit to work with respect to time. Because when we say the product or the equipment will work for the intended function for a specified period of time, so it should be fit to work. Should not fit to work, when we say, means it should not give any problem, any deviation from its performance. So then we say fit to work. Or it should not fail during that period of time. Then we say the fit to work. Second thing is the capacity of the device of the system to perform as designed. We say that every device or the equipment has been manufactured with a consideration that it will produce a required number. When we say capacity, required number. So we say that the capacity, we say with quantity. The resistance to failure of a device or system means it should not fail for that specific period of time. The ability of a device or system to perform a required function under stated conditions, whatever condition, because the condition has been specified by the manufacturer, that this system will work, the equipment will work without any problem if it will be operated under these conditions. Conditions may be a temperature under the environment, maybe under this you say the operating condition, maybe say the skill of the operator. So these are some of the parameters on which we say the stated conditions will be given by the manufacturer. Another important, the probability that a functional unit will perform its required function for a specified interval under the stated conditions. So if we are following the stated conditions and we say the product or the equipment will perform its function for which it has been designed and it has been manufactured, it will give those required functions. For more definitions, we say the ability of an item to perform a required function under given conditions for a given interval of time that we have given and expressed as a probability. So probability, when we say, it is between 0 to 1. Okay, so whenever we express the reliability, we give in percentage to 100%, that is 50%, 60%, 70%. So if you say reliability is 70%, means out of the total 100 hours of operation, 70 times it will work. 70 out of 100 it will work satisfactorily. So the reliability of a component may be expressed as 99. So when we say 19, it will never say 100. Always expressed as a maximum means 99, means 99 times of the time, that is, or you say there is a probability that 99% the functional or you say the equipment will work satisfactorily without any problem, that it will work successful at least for the given period. Here we have written 1 year, but this is not 1 year, this is the specified period. Minimum, when we say the guarantee, 1 year we have written, considering that for every equipment we give the guarantee of 1 year. That if the equipment has worked for 1 year without any problem, it will continue to work for a longer period or for a period for which it has been designed or specified. The reliability essentially an indication of probability that the item will not fail in the given period. That we say, we express that the function of the equipment in terms of the probability of survival, no problem. The generalized curve for the failure rates of the component over time is the bar-top curve, which consists of the three parts: the early period of curve, where a number of failures result from manufacturing, assembly, commissioning, setting to work problem. Maybe you have seen, I'll show you the next slide, how it behaves, the bar-top curve. Early period, when you say a continuous, you say very fast decrease, you say very high failure rate. Number of failure results from manufacturing, assembly, commissioning, setting to work problem. when all the teething problems have been eliminated, the population has a useful life, over which the items fail at a relatively low rate. After a long operating time interval, the items will fail at an increased rate due to wear and other time related functions. Okay. So this curve applies mostly to electronic components as which are operated continuously to define items that we call burn-in prior to its delivery to the user. Now just have a look of bathtub curve, which consists of three parts: decreasing failure, constant failure, and increasing failure. So the first part, because of maybe the manufacturing defect, or the manufacturing defect, or the processing defect, or assembly defect. And the second part, which we call is constant failure rate, which we call the useful life of the component. During this period, we use the product, we use the equipment, and then after a specified usage of the component or the product or the equipment, then we say the failures will increase because it has completed its target of functioning for a specified period of time. So now we say another way of defining this curve, we say rate of early, that we call infant mortality failure when first introduced, the rate of random failure with constant failure rates during its useful life, and the rate of wear out failure as the product exceeds its design lifetime. So this is related to the bathtub curve, which I have explained. And so the last sentence of this is, although the curve is useful, but every product or system don't follow a bathtub curve hazard function. For example, if units are retired or have less use during or before the start of the wear out period, units will show fewer failure per unit calendar times, which is against the bathtub curve. So in the bathtub curve, we have given that after this point, you say initial period, we say the constant period, then it increases. Means after a specified period, the failures increases. But when you say the component or the equipment or the system has not used during that period or less used during that period, then the number of failures will not be as specified in the bathtub curve. Okay. So that is the the concept of this which you want to say. For mass-produced mechanical items, the quality control method is used to ensure high reliability and uniformity of production, because you know that is quality is very much related with the reliability, or we say the quality is a subset of reliability, because we measure the performance of the equipment in term by measuring the quality. What is the quality of product it is producing, or quality of function it is giving. So with that, because we generally measure the quality, control the quality, and we say if the equipment or the system or the product is producing or giving a quality services, then definitely we say we can trust on the equipment, we can trust on the system, and we say it is reliable. Okay. So before sending the product to the market, they are rigorously tested to identify and to correct the design and manufacturing defects. This is a very big sentence written here, because once the product is in the market, in the hand of the customer, okay, so the customer never bothers how it is produced, who has produced. He only concerned with his satisfaction that the functional guarantee he wants, that is the operational guarantee he wants, that for which he has bought this particular product or the item, he must function, he must do the function and for that specified period of time. And you say even probably if the system or the component is highly reliable, then even after the over of the specified period, the equipment will work satisfactorily, no problem. That again we say we built a product or we manufactured a product with a factor of safety. With a factor of safety means if we say this product will function for 100 hours, let us say, or for 100 days, or for 10 years, let us say we say, so we have to design it for 11 years, for 120 days, or for 120 hours, like that. That is, some safety margins will keep. So for that purpose, we say the product will work satisfactorily without any problem up to that period. Okay. So that will, you say, give the more satisfaction to the customer in terms of its functional without any problem. One of the main targets of design, manufacturing and operation is to increase the useful life. The factors which we look are strength, life safety factor, tribology consideration, corrosion prevention, protection against environment effects, fatigue, vibration, regular service. There is some disturbance? Okay. In a system, if the equipment components are in series, then the overall reliability is the product of reliabilities of the individual equipment. I'll give you that expression also. And when the active equipment or the component are in parallel, the resulting reliability will be improved. Means you say the reliability will be higher. You say, so we say in parallel the reliability will be higher, but you say it will increase the cost of the equipment. Okay. So mathematically, reliability theory is the foundation of reliability engineering. For engineering purpose, reliability is defined as the probability that a device will perform its intended function during a specified period of time under its stated condition, and mathematically we express t to infinity from the starting point t up to t infinity. Here we have mentioned, but t we say the specified time fx dx, where we say fx is the failure probability density function and t is the length of period of time which is assumed to start from 0. Okay. Invalid concept for modern concept complex system. Some investigation in the aerospace and other industries have discovered that most failures do not comply with the bathtub curve. It is argued that the bathtub curve is an old concept and should not be used as a stand-alone guide to reliability. But when it was tested, most interesting in these investigations was the conclusion that wear-out issues in complex systems only count about 4% of all failures that can refer to RCM, reliability-centered maintenance concept. So means most of the component, even complex system, follow the bathtub curve. Only in some specified things we are saying that the bathtub curve, curve has not been followed. The reliability-centered maintenance concept has been written that in some cases we have observed that it is not following the bathtub curve. A specific case has been written here. Okay. Second point is, first is reliability, then availability. What is availability mean? Probably many of you have heard this word also. The availability. Availability, we say the ability of an item to be in state to perform a required function under given condition at a given instant of time or during a given time interval, assuming that the required external resources are provided. Means the external resources will be given by the manufacturer, that these must be the external resources which must be ready to work for the product. So we say here in simple words, the availability will be uptime to the downtime plus uptime. Okay. And we say from this is also the time units are generally hours and the time base is 1 year. When it is converted into hours, it is given here. From the design area of concern, this equation translates to availability equal to AI is mean time between failure and to mean time to repair. Okay. And the operational availability is defined differently. That is, availability is operational availability is MTBF to MTBF plus mean downtime. Okay. Now the third word is the maintainability, which is the main concept of the industry. That is how easy is to maintain the equipment or the system. The ability of a system or the item or the equipment under given conditions in use, the word is written in use, to be retained in or restored to a state in which it can perform a required function when maintenance is performed under given conditions and using stated procedure and resources. So all the word written here, each word has a meaning. Now we say the last word I read only, when maintenance is performed under given condition and using stated procedure and resources. So we say when equipment is supplied by the manufacturer, the manufacturer will give the manual, how it will be, what are the different components, how they will be repaired or replaced, and you say what will be their replacement period, time, and then how they will open, or you say they will be removed and then will be stopped. Okay, so that procedures will be given by the manufacturer. So we have to follow that procedure. Only then we can say that the maintenance can be performed easily, quickly, without any problem. So it is a measure of ease and rapidity. Now the word is ease and rapidity with which a system or equipment can be restored to operational status. The main purpose here to mention the point here, ease and rapidity, means when the system will be down or the equipment will not function, so you have to take out the system or the equipment from the operation place and then send it to the repair shop, will be repaired, will be done, and then it will be brought back to the position. So the time to start the repair, time to work for the repair, and then putting it to the place, it will take longer time. So then you say all things must be easy and how rapidly you do the action. Okay. The example I can give you of the sports car. When the sports car will be in operation, when will be on the road, then all the operation, when you say the changing of the tire, filling of the, you say air, or you say whatever may be the thing, is so quick, automatic, that it takes only a few seconds, you say, to do the operation of maintenance. So that is the meaning of ease and rapidity. When an equipment fails, it is important to restore it back operational as early as possible, called maintainability. So maintainability or mean time to repair of an item, the time required to perform each anticipated repair task is multiplied by the relative frequency with which that task is performed. For example, number of times per year. How many times the task has been performed. Mean time to repair data supplied by manufacturer will be purely repair time, which will assume that the fault is correctly identified and the required spares and personnel are available. The mean time to repair to the user will include the logistic delays. It also includes factors and skill of the maintenance engineer or maintenance personnel. So here the word, because we say, as I have mentioned here, the repair will take time. Repair not only, the repair is not included only the opening of the component or you say disassembly of the equipment and then doing the or you say replacing the component and then assembly of the equipment and then putting it on the disk. It says including logistic delay, start of the work, and how the work will be performed. When means the required skill, open of all the you say component, the disassembly of you say taking all the component out and then putting the component on the place, in the place you say. So mean time to repair user factors are detection of fault. How the faults will be detected means, for example, we say if an equipment is doing some noise, okay, means some noise you hear. So the noise if you hear, then you have something in your mind that there may be some problem. For example, your car is making some noise, more noise you say. Then what you will do? You will not be able to understand what is the cause of this more noise. So then you will go to the mechanic. So mechanic is just listening the noise of the, you say, or the sound of the car. He will be able to understand or recognize that where the fault may be. Maybe when you open the bonnet, he opened the bonnet and touch some point, then automatically the sound goes. Okay, the noise goes, you can say. So that is the meaning of how he diagnosed the problem. Okay, so that is the skill of the operator, skill of the maintenance personnel, that he identified, he diagnosed the problem. So when he diagnosed the problem, he diagnosed the correct problem, then he will rectify the problem quickly without any delay. So that is the meaning. It includes the fact skill of the maintenance personnel. Okay. So detection of fault, then startup maintenance team. So when you say his system is complex, the equipment is complex, then how he starts the work? Diagnose fault. Where do you say faults are there? To diagnose all the faults. Then obtain the spare parts. So spare parts will be, that is, they cannot you say demand the spare parts in advance. Only once the equipment will be opened, the fault will be detected or fault will be diagnosed, then they will demand for the spare part. That is, this spare part is needed. So if that spare part is not available, for example, in the store, then again we say the delay of doing the repair will be there. So means, so that is the say that is the skill of the maintenance engineer or the skill of the operator, that he will diagnose the fault, he will give the reaction that this may be the possible fault in the, and these spare parts may be needed. Just check in the store whether we have the spare parts or not. Repair, meantime to repair, manufacturer's information. That is, sometimes you say the manufacturers always give the information that this may be the problem related to the particular component after this period. So you check it, you replace it. Test and accept the repair and start up the equipment. Okay. So the maintainability we define more specifically a characteristics of equipment design and installation, personal availability with required skill level. Now the word you just read, equipment design and installation, means how it has been designed and installed at the place, and which requires a particular skill level that must be available to operate that particular equipment. Adequacy of maintenance procedures, what procedures had been laid down by the manufacturers, that is the meaning of the adequacy of maintenance procedure. And test equipment and the physical environment under which the maintenance will be performed. So maintainability is expressed as the probability that an item will be retained or restored to a specified condition within a given period of time. Now the word is written here, within a given period of time, means if we say that the component will be replaced or replacement time is 50 minutes, 40 minutes or 1 hour 30 minutes, then it must be done during that period only. Okay. So probably if you have seen about the repair or repair mechanics observation, you just ask how much time it will take. For example, if you go to a repair mechanic for repairing of your vehicle, then you just ask how much time it will take. So he'll say 1 hour, half an hour, 2 hours or 5 hours, whatever we say period. So that is based upon, because he has the experience to open all the parts, do the, you say, work and then to assemble that you say component. That is, within a given given period of time, when the maintenance is performed in accordance with prescribed procedures and resources. Okay. Now another term which we define in the reliability is failure rate. We express by lambda into T, the frequency by which an engineered system or component failure per hour depends on time, the total number of failures within an item population divided by the total time expended by that population during a particular measurement interval under stated conditions. The rate varies over a life cycle of the system. Failure rate of an automobile in its 5th year of service may be many times greater than its 1st year of service, because we say that the any component or the equipment or the system in first period it remain new, and you say the failures are 0 or no failure will be there, or it will you say function without any problem. But after you say that, we say the guarantee period, and that the guarantee is taken by the manufacturer, supplier, that this is the guarantee, and that we say the meaning of the reliability, that there will not be any problems for the system, for the equipment, for the product for this much period of time. And if for that period all will well, then it will go for you say for a longer life. Generally, mean time between failures is expressed as 1 by lambda, that is the 1 by the failure rate, is reported instead of the failure rate. It is valid, useful, as the failure rate is assumed constant, often used for complex unit systems, electronics, and is a general agreement in some reliability standard, which we say the military and aerospace. It relates to the flat region of the bathtub curve, which we call the useful life period. Okay, then next part of this is failure rate. How we explain the failure rate is the reliability failure rate between the period of T1 and T2, because we say the start period is, if it is, and we start with T equal to 0, then delta T we are defining with T2 minus T1, and lambda T will be a function in the conditional probability of the failure density function. The condition is that the failure has not occurred at time T. Then R, reliability at time T1 minus reliability at time T2 divided by T2 minus T1 to RT1. Okay. So hazard function is also defined, so we'll skip that also. Now we come to the reliability engineering. It deals with the study, evaluations, and life cycle management of reliability. The ability of a system or component to perform its required function under stated condition for a specified period of time. Reliability is measured as probability of failure, as we have already mentioned, frequency of failure, or in terms of availability. A probability derived from reliability and maintainability. Maintainability and maintenance are often important part of reliability engineering. So here why I am adding the reliability engineering, because we are saying here frequency of failure. How many times the equipment will fail during the period of time. If it has no failure between the specified period of time, then we say the performance of the equipment is good as specified. We say, okay, it is closely related to the safety engineering, where common methods for their analysis and all inputs are required. So here my point here is, when we call about the reliability engineering, we count number of failure, and then we count the period for how much time it takes to repair it to put into the operation. That is the meaning here. We say reliability engineering. So reliability engineering focuses on cost of failure, how much it costs to the industry, cost by system downtime, cost of spare, repair equipment, personnel, and cost of warranty claims, while safety engineering focuses on preserving life and nature. It is more useful for complex system requires a different, more elaborate system approach than for simple system. Means when we are taking a system, means we are combining number of component or number of equipment in a system. Okay. Reliability analysis means functional analysis, requirement of a specification, system design, hardware design, software design, manufacturing, testing, maintenance, transport, storage, spare parts, operational research, human factors, technical documentation, training, and more. So these are some of the things which are the part of the reliability engineering. So effective reliability engineering requires experience, because we have to judge, we have to see, we have to forecast how you say the equipment will function, behave when it will be put into operation. Broad engineering skill and knowledge from many different fields of engineering. So, because when you say a maintenance engineer in the industry to look after the various, you say, equipment, different type of, you say, system, so he must have the experience of either of that particular system, or if he has worked in a different system, then he must have the knowledge of the equipment which are there of operation in the system. So generally in the industry we say the system are arranged either in a series or a parallel basis or a combination of both. So here we have mentioned a simple system where the system A, system B in parallel, system C and D. So A, system B, we have to calculate for system B what is the reliability, and then we have find out the reliability of the total system, which is a combination of series and parallel. Okay. So reliability engineering is a special discipline within the system engineering and rely heavily on statics, probability theory, and reliability theories to set requirements. Means we have to set the requirement, we measure or predict the reliability and give advice for improving the reliability performance. How we can improve the reliability performance? Means the point is that we have to get a feedback from its operation system. When the equipment or the system will be in actual operation, then we should get feedback that how the different component or how the different system or how the different equipment have worked during their operation, and what is the, you say, drawback of their operation, what is the inefficiencies of the operation, and then that inefficiencies will give to the designer. So he has to modify in terms of modify the design, change the material of the component, change, you say, in you say different shapes that will, you say, so that the required function must be achieved when they will be in the real operation. You say the techniques used are reliability, hazard analysis, failure mode and effect analysis, that maybe some of the term you have heard, fault-free analysis, reliability prediction, variable distribution analysis, thermal management, reliability testing, and accelerated life testing. Due to many available techniques, their expense and the varying degrees of reliability requirements for different situations remain under the consideration. So my point here is, writing of this sentence is that depends upon, for example, we say the medical equipment. When we say the equipment in OT, operation theater, where you say, so there you cannot tolerate the inefficiency of any, you say, in operation. So, okay, similarly, the war equipment or war machine, you say, at war footing. So then the inefficiencies of any equipment or the vehicle cannot be tolerated. So there you say the expense are not important. The operation is the place where we are using that, because there is important, because the strategy which we have made will be, you say, will be affected, or you say there may be a question of winning the war or losing the war. So that similarly in the case of the aerospace engineering, or in the case of when you say in the aeroplane, so there also the high safety is required because of the risk of human life is there. So depending upon for which component or for which system, for which machine you are considering the reliability parameter, maybe for some machines you have to say that should be 100% reliable. For that period, there should not be any failure. For example, you say if a war jet is going to, you say, for bombing purpose, and they say slight missing of the target in a fraction of second will also affect. Okay, so that is not desired because of the high cost of these equipment. You say to create safety, a robust set of statistical evidence and justifications are searched and verify the requirements of maximum reliability or availability. The goal is to first identify the reliability hazards, assess the risk associated with them, and then control the risk to an acceptable level. So it depends upon where you are using the equipment, where you are using the machine, and how much you say risk to human life is there, or risk to the system is there. Because at many places we cannot tolerate the unavailability, or you say the failure of the system. Okay, the acceptable limit is determined by the managing authority or customer, normally managed by a reliability engineer or manager. So that is the duty of the reliability engineer or reliability managers to specify that for this particular component, for this particular equipment, we need this much reliability. Okay, so accordingly, it will be built in design, it will be built in manufacturing, that the component, or we keep high safety factor. If we will keep high safety factor, then at least for that period of time, there will not be any problem in the operation or in the function of the equipment. Reliability engineering closely associated with maintenance and logistic engineering. For example, integrated logistic support. Almost all disciplines of engineering use the tool and methodology of reliability engineering, and is performed throughout the entire life cycle of the system, including development, test, production, and operation. So only I'll read the last sentence. The operating environment must be addressed during design and testing. So here my point here, because the reliability is restricted to the operations under stated condition, so the designer, and during the test, it has been given that in what environment or in what conditions the system will operate, should operate, that you say, or in what environment the system will give the best performance. Functions of reliability engineer: develop the reliability requirement for the product, establish an adequate life cycle reliability program, show that the corrective measure, reliability, risk mitigation has been taken for reliability improvements, perform appropriate analysis and tasks to ensure that the product will meet its requirement. The unreliability risk is controlled and brought to an acceptable level. Now we say the reliability programs plan. Many task methods and tools can be used to achieve reliability. Every system requires a different level of reliability, as I have mentioned earlier. A commercial airliner must operate under a wide range of conditions. The consequences of failures are grave, but there is a correspondingly higher budget. Means if you want to achieve a higher reliability of the system or the machines or the equipment, definitely as I have mentioned, the testing will be very rigorous. And in these simulated conditions, environmental conditions, so then you say we can say manufacturer, for example, you say Boeing is operating for last so many years, and its reliability is very high. And you say not only this thing, the company get the feedback from any of the disaster when occurs. Probably you know that every you say plane has a box, black box, if you say, and where you say all the data are recorded. And when you say when there is a disaster, this box has to be collected and goes to the company for decoding of what you say. So all data are recorded. Every you say data of every moment of data you say are recorded in that box, and that box are decoded by the company. Will check what are the basic reasons why the disaster has occurred. So that is the meaning here. We say to get the feedback of the parameter occurrence during the operation of during the function of the system. A reliability program plan is used to document exactly what best practice, task, methods, tools, analysis, and tests are required for a particular system or subsystem, as well as clarify customer requirement for reliability assessment. Means how we will assess the reliability, that means the customer. You say for large scale complex system, the reliability program plans is a distinctive document. Means if it is for a company, means some you say a complete setup has been made by you say some designer. Then you say because it's a big thing, so then the distinct document has been prepared, how it will operate, how it will function, how you say all the parameters will be considered. That is the meaning of reliability program plan is a distinctive document for that particular system. For simple system, it may be combined with the system engineering management plan or an integrated logistic support management plan. A reliability program plan is essential for the successful reliability, availability and maintainability RAM, which we say program, and is developed early during system development and refined over the system life cycle. So means whenever we are saying a new system or new equipment you are doing, then the plan has been developed, but you say refinement will be done when it will be in operation. Okay. It is specifying not only what the reliability engineer does, means what he does, what he thinks, but also the task performed by other stakeholders, means how other stakeholders do the things, will do the function, will operate it, and then will give the feedback. Okay. Technically, often the main objective of the reliability program plan is to evaluate and improve the availability of a system and not the reliability. Means when we say the availability, means the system must be available when it is desired for the functional or the work. Okay. This also we skip. Now the reliability requirements are for any system, one of the first tasks of reliability engineer is to specify adequately the reliability and maintainability requirement as defined by the stakeholders in terms of their overall availability requirements. To address the system itself, including test and assessment requirement and associated tasks and documentation. To address appropriate system or subsystem requirement, specification, test plan, and contract statements must be there. To address maintainability requirements of the system related to the cost and repair time. So these are the things, these are to be given. The effectiveness of corrective measures is in evaluation process a part of FRACF, that is failure reporting analysis and corrective action plans process, a part of good RPP, reliability prediction procedures, carried out using software to provide reporting, classifying, analyzing failure, and planning corrective action in response to those failures. So the purpose of writing this sentence is, probably nowadays you know that when a car, automobile, will go to the workshop, they will put on the test bed, and it will, you say, start in the starting mode, and you say doing this. So it will identify where the fault is diagnosed, you say, with the sound, with the operation, So it diagnoses that where the fault may be, and maybe in some of the big brand or the vehicles, you have found that on the control panel also some alert you'll observe that the indication that there's some problems on the engine, there's some problems on this tire, some problems on this, so some alert may be there. So that is the purpose of that if you say there will be an alert, then you will be cautious that some problem is there. You will go to the mechanic, you will get check your vehicle, and you will try to rectify the problem immediately. Okay, so that will help for avoiding any accident or undue things. Okay. Method wise, I'm skipping this also. Text requirements. So this is also I have explained the mean time to failures we need. Now next part is software reliability. It is more challenging areas that must be considered when it is a considerable component to system functionality. That as I have indicated you, in the case of the automobile, functional, will be reported on the panel. Means a slight deviations in the functional of the component will be indicated that there is some problem on this particular component, and the alert will be there. When there will be an alert, if you say all the component or major component or where a problem may arise, so if it will be on the panel, so it will be in your mind that this is the problem in this component, and if it will not be corrected immediately, then this may create a lot of problems like this. That is the main usage of the software reliability. Okay. The for system with a clearly defined failure time, sometimes not given for system with a drifting parameter, the empirical distribution function of these failure times can be determined. This is done in general in an experiment with increased stress. These experiments can be divided. Okay, so the last I'll read in so-called zero defect experiment. Means we have to produce the component or the equipment or the system where we say there will not be any problem, will be zero defect, or there will not be any failure during this period. Only limited information about the failure distribution is acquired. Here the stress time or the sample size is so low that not a single. So I'll just now another is design for reliability. Design for reliability is an emerging discipline that refers to the process of designing reliability into design. So at the stage of design, so designer has been given the task to design the component. Means when we say designing may be related to the shape, functional shape, and second is the material. What material will be used in the design? What material will be used, or what will be used during manufacturing? That will be specified by the designer. That these are the means related to the strength, related to the functional capability. The process includes many tools and practices, describes the order of their deployment that an organization need to have in place to drive reliability and improve maintainability in products. The objective is to improve availability, lower sustained cost, and maximum product utilization or lifetime. DFR process is to establish the system availability requirement. Reliability must be designed into system. During system design, the top level reliability requirement must be allocated to the subsystem by design engineers, maintainers, and reliability engineers working together. Reliability design begins with the development of a system model. Reliability models use block diagrams and fault, as I have mentioned, indicating the liability. That is, we use a liability block diagram. We give the liability of each block, and then we'll analyze to find out the total liability of the total system. Now, the commonly used task, technique and analysis, which we generally adopt in industry, built-in text. That is testability analysis, we say, failure mode and effect analysis, liability simulation modeling, liability hazard analysis, liability block diagram analysis, fault tree analysis, root cause analysis, snake circuit analysis, accelerated testing, liability growth analysis, Weibull analysis, thermal analysis by FEA, or finite element methods or FEA or measurement, thermal induced shocks and vibration fatigue analysis by FEA, electromagnetic analysis and statistical interference. Avoid single point of failure, functional analysis, predictive and preventive maintenance, reliability centered maintenance analysis, testability analysis, failure diagnostics analysis, human analysis, operational hazard analysis, manual screening, integrated logistic support. Results are presented during the system design review and logistic review. Reliability is just one requirement among many system requirements. Engineering trade studies are used to determine the optimum balance between reliability and other requirements and constraints. So the last sentence, last paragraph written is in other, you say, because when we are saying reliability, we are indicating with the performance of the equipment. And when we say the high performance means increasing of the cost. And reliability, when we say reliability of all components, all systems, we say. So reliability, you say other requirement when we are writing the other requirements and other constraints. Constraints may be of the money, cost. Constraints may be other functional, means say aesthetic also. So depending upon where or what function this system or the equipment or the items will work or where it will be. So maybe sometimes the other requirements are more important as compared to the reliability. Some you say some are the constraints under those constraints we have to design, we have to make, we have to manufacture the component. That is the meaning of other constraints we are saying here. So this also we skip. Accelerated testing we also skip. So another important product life cycle management. In industry, it is the process of managing the entire life cycle of a product from its conception from its inception to design and manufacture to service and disposal. Product life cycle management integrates people, data, processes and business systems and provides a product information backbone for companies and their extended enterprise. The purpose of writing the product lifecycle management is because we are talking here the reliability for the purpose of industry. When we are saying in the industry, as I have mentioned, you say in my earlier lecture, that is from the starting to the end, the raw material will be brought at the first point. Some processing will be done at the first point, means some value will be added, and then it will be transferred from first machine to the second machine. Some value further will be added, then transferred to the third machine, and so on. This process continues. So the point is here, the product life cycle management integrates. When we are saying integrating, people, those involved in the process. Data processes, how the data at each stage are gathered, collected, and then processed. And you say, what is the strategy of the business system, how the business system is, and provides a product information backbone, means related to the product, means when the product will be finished product or product after the sales, you say, so how that you say the product has been used, so that will give you a, you say will be a feedback, we'll see will be for the back will be a backbone to the companies and for their extended enterprise. Okay. PLM system help organizations in coping with the increased complexity and engineering challenges of developing new products for global competitive market. So this sentence I have written for the purpose of that nowadays we have a global competition. For many products, for large number of products, we have a global competition. When we have a global competition, means the objective is to add more feature in the product. From you say that is to produce the product more reliable, more you say and cost effective also. Means at low cost we have to produce a better with higher feature. For example, I'll give the example of automobile. In automobile, there is a huge competition in the automobile. In the same segment of car, you will find that in the same segment of car, the number of companies are giving more features, are adding more features in your car, and then you will go to that car only which has more features and more reliable. Okay. So according we say apart from the reliability, the feature also is a factor which you can call the other factors which attracts the customer to buy the product. Okay. So PLM this should be distinguished from the product life cycle management. It describes the engineering aspects of a product from managing, describing and properties of a product to its development and useful life. Whereas the CM refer to the commercial management, commercial product life commercial management of a life of a product in the business market with respect to the cost and sales measure. So this is also very important in the commercial management. We have to check because in the commercial management that is different from the product life cycle. PLM is one of the four cornerstones of a corporation information technology structure. All companies need to manage communications and information with their customer relationship management, their suppliers, SCM supply chain management, their resource with the enterprise ERP, enterprise resource planning, and their planning SDLC, system development life cycle. In addition, manufacturing engineering companies must also develop, describe, manage and communicate information about their product. So this all about that is the different system or subsystem we are establishing for attracting the people, adding the features for testing for the purpose of collecting the data and then putting the the equipment or the product into the market to attract from all points, from all features. One form of the PLM is called people-centric PLM. While traditional PLM tools have been deployed only on release or during the release phase, people-centric PLM target the design phase. Okay. Now, benefits and application of this documentation benefits of product life cycle management includes reduced time to market, improved product quality, reduced prototyping cost, more accurate and timely required request for code generation, ability to quickly identify potential sales opportunities and revenue contribution, a framework for product optimization, reduced waste, saving through the complete integration of engineering workforce, documentation, ability to provide contract manufacturers with access to the centralized product record. And the area of PLM, within PLM there are 5 primary areas: system engineering, product and portfolio management, product design, then manufacturing process management and product data management. So this is a pictorial view of the product life cycle management, where you say all features or you say their attributes are incorporated. So I'll skip this also. Now the other part is the evaluations of the reliability. Reliability, when as I mentioned you, the system or the component are considered to be in either in series or in parallel or a combination of both. One more term I have added here, redundancy model. R out of n model. R out of n model means you have n component, and out of n component at the time R is working. The rest remains, you say, unoperative during a period. When we say the redundancy model means they are element redundancy, unit redundancy, or the standby redundancy. Element means a component. A component. Unit means a complete unit redundancy. Or standby redundancy when you say a complete system will remain in a standby. When we say the standby, there will be two another cold standby and the cold standby. In mechanical component or mechanical system we have cold standby, and in electronics component or the system we have hot standby. So this will not explain much, but you can just have a look of this, that when the component are arranged in series, then the reliability will be a product of all reliability of all components. Okay. And when they will be in parallel, then 1 minus R1, 1 minus R2, product of 1 minus, and then 1 minus 2. Okay. What is R out of n model, and then you say the expression for R out of n model. Now the meaning of redundancy, just have a look of this. It is just as parallel model. In this we are adding redundant elements to each. Just have a look. Parallel model or a parallel we are not calling the redundancy. When the system is in parallel, when the system is in parallel means we are increasing the capacity. We are increasing the capacity of the operation. Okay. So if you, as I mentioned, as I indicated you, a system where A, B, we have a number of equipment in parallel, C and D. So means in the industry, the parallel system is to be in function when you say the operating time of the first machine is less. Operating time of the second machine is more. So means say to maintain the continuity of the process, when you say the operation time of the first machine is less, means say in a given period of time it will produce more component. And you say when the processing time of the second machine is more, so it will produce less component in a given same period of time. So you have to put more machine to produce the same number of component in the same period of time. Okay. So that is the meaning of the the parallel component. But when you say the redundancy means a parallel, the same component, same equipment or same component in parallel. Only the one component will work, another will remain silent, we say non-operative. That is the meaning of the standby component and the parallel we say here. Unit redundancy, to improve the reliability of a system, we provide a redundant unit either to each and every subcomponent or system. For example, we say a complete assembly or unit, we say we have a standby. That is means when this unit will fail, then the second will be put into operation. Okay. So that may be an automatic process, that may be a manual process. Considering the following cases: no redundancy, redundancy units to the whole system, and redundancy elements to each subsystem. For example, I say the in electronics component, the power supply will be in a backup power supply will be there. Backup power supply there means if this will fail, this will be in function. For example, you use the UPS. UPS for a period, you will see there is a backup is there. That is for 5 minutes or 10 minute backup will remain, so that your function, your equipment or your computer will remain operative for 5 minutes, 10 minutes, 15 minutes, or 1 hour, whatever may be your backup you have. So you will not suffer, that is, of non-availability of the power. Okay, that is the meaning of unit redundancy meaning here. So just having no redundancy units with the whole system, and redundant elements to each subsystem. So just have a look, and the expressions we can read here with the redundant items. Okay. Element redundancy. Okay. Sorry. Another, you say, just have a look. Standby redundancy. In the PAL system, all the elements, all the channels or paths are active from the beginning of the operation of the system till failure. Okay. In a system, standby system, all the paths are not active at the same time. If element A1 fails, then the decision switch sends this and the connection is made to the standby element. So in mechanical component, we say A1 and A2 switch are there. While in electronics component, we say the both circuit will remain operative. Only we say the switch is there. That is, automatically when the first circuit fails, automatically second will come into operation. You will not be able to understand that is whether the equipment is operating under the first circuit or under the second circuit. Let's have a look for PAL system. Now the second part of your today talk will be maintenance. That is, first is reliability, and second part is maintenance. That is, once the equipment will put into operation and is not functioning well, is not behaving well, then we have to remove it from the place and doing the things for replacement, overhauling, whatever may be the maintenance function we say. So we have to first say what is the maintenance column. We say due to continuous usage of the equipment in a plant, the occurrence of equipment deteriorations is a natural phenomena, and more deteriorations will cause their failure, resulting in production loss. So when you say the equipment in line is not operative or is not behaving properly, then you have to put it out and you take it out, and the production will suffer. Okay, that you don't desire. So maintenance, we say, is an activity to maintain the facility at a level which will reduce the likelihood of failure to minimum. So we want that this failure should not be there in the specified period of time. Maintenance is a routine and recurring process of keeping a particular machine or assets in its normal operating condition so that it can deliver its expected performance. Now, the word here is expected performance or service without causing any loss of time on account of accidental damage or breakdown. So, generally, to observe this, we either we sense it with the sound, vibration, temperature rise, we sense. For example, you say when you say the rotors are rotating in the bearings, and you say you will find a sound or the temperature rise of the bearing hissing, then you will say there is some problem. Either the greasing is not there, or some you say in the balls or you say rollers of the bearing will not, they are not, you say, functioning well. So means there may be a chance of breaking. So if you say the bearing will, you say failure of bearing will be there, then what will be? A sudden vibration will start in the movement. Okay, so that you don't, that may cause another, you say, problem. So factors which force the management for maintenance: increase in number of size, complexity and variety of physical assets. Growing awareness of the impact of maintenance on the environment, safety of people, those who are working around, profitability of the business, and quality of the product. Because if you say the equipment or the part is not functioning well, then it will not produce or the function will not be proper. So defects will be generated. Requirement for high-speed maintenance system, correct and long-term forecasting, correct usage of material planning and control system, adapted planning environment, stable system availability, and the maintenance involves setting of objective, planning, executing and controlling maintenance functions as a corporate policy and strategy. Because many times the corporate strategy or the policy is not to spend more money in the maintenance, because in industry we say that the composition of the maintenance people are, we say, maintenance crew, and maintenance crew size may be 10 to 15 people, where highly skilled people are there, where the lower skilled, unskilled people are there, and semi-skilled people are there, and we need the tool and the equipment also to do the operation of maintenance. Okay, so maintenance, we say, is a combination of several actions carried out in an orderly manner or to repair, service or replace the component or numerous equipment in a plant or system such that they continue to operate for a specified time period. So now what here again we are saying is specified time period, and if for any equipment you found that the reliability is low, or you say there is a chance of failure, you keep the standby. In industry we don't, we say we cannot tolerate the loss of production. When we say we cannot tolerate the loss of production, depending upon the criticality of the equipment, the survival of the equipment, we have to maintain a standby, you say, so that, and if you know that the place is there where the people cannot work, you have to take it out and then go for repair, and only the solution will be take it out, keep a new one there or repaired equipment there, and then we say, so that your operation will continue without any, because the replacement will take comparatively lesser time as you say compared to doing the maintenance on the site. Okay. Now some challenges in the maintenance are rapid growth of technology, resulting in current technology become obsolete. Because you know that nowadays the technology are changing at a faster rate. And so the point of, you say, when we are saying rapid growth, you will say the rapid growth of technology is very good. But it is good, but the people, those who are doing the maintenance, they are not aware of the rapid growth of the technology. So they must be aware of the rapid growth of the technology, then only they will be able to understand how the maintenance of the things will be done. For example, now you will have a complex automobile with high features of automobile. You will find that the mechanics will not be available here. Specifically in a small city or in a big city also, for a particular, for example, you say the Mercedes car with a, you say or a BMW car, you cannot find all mechanics can do, or you can do the operations of, you say, mechanic repair of this high-ended, you say, product. So many times it becomes difficult. That is the meaning of the technology, you say, or the features which has been added in the product. Advent of new advanced diagnostic tool, rapid repair system, advanced store management techniques to incorporate modular technologies, requirement of keeping both outdated and modern machine in service. Activities of maintenance department. So we say, as I mentioned you here, every industry has a maintenance department. And the composition of the maintenance department is that there is a maintenance manager. Under the maintenance manager, a maintenance engineer. Under the maintenance engineer, there are few junior engineers or assistant engineers. Under the maintenance engineer, there are number of you say supervisors, we say, and under the supervisors again we say a group of people are there. Maybe group of people mean highly skilled people, semi-skilled people, and unskilled people. Highly skilled people are to, you say, the specific or the people with a specific knowledge of particular equipment, particular system. So they have, you say, they are, you say, they are for the purpose of doing the specific or specified maintenance only. For general, the other people will be in the same system. Okay. So activities of maintenance department is upgradation of existing plant and equipment, training of maintenance personnel to attain the required technical skill, to acquire, not required, to acquire the training technical skill, effective maintenance of the old equipment for higher availability, post optimizations of all maintenance functions, improvement of maintenance activities, reconditioning of the used or unserviceable spare parts, development of indigenous sources for spare parts for import substitutions, setting up of an effective maintenance information management system. Now, this setting up of an effective maintenance information management system, the purpose of writing this effective maintenance information management. Now we have a computerized maintenance management system, where we say all the informations are recorded in the computer, are placed in the computer screen, and anybody can access anytime. Who has done, what has been done, how much time it has been taken. Okay, so all these things we say effective utilization of the maintenance workforce, setting up of in-house R&D activities for effective improvement in maintenance practices. So R&D, when we are saying setting up in-house R&D activities, means many equipment or the items are imported items. So when we say we are buying it, you say from other countries, so we have to either we have to call every time the person from that manufacturer, or we have to generate the indigenous, you say, in-house facility, so that we'll know the functional of each component. So when you say the problem arises, so that our people can rectify it easily. So we say here, what are the factors which are affecting the maintenance structure? Size. What is the size of the organization? If the size of the organization is small, then only few people can work. If the size of the organization is a big, maybe big in terms of the quantity. If it is producing, you say, higher quantity, maybe you say 1,000 components per day, 1,000 items per day, or 1 lakh items per day, if they are producing, then we say more automations will be needed. Then complexity of the plant, how complex the plant is. Okay. Then type of product produced, what type of products we are producing. Okay. The steps for managing an effective maintenance program are: identify existing deficiencies, set maintenance goals, establish priorities, establish performance measurement parameters, establish short and long range plans, document both short and long range plans, and forward the plan to all concerned, implement plan and examine progress annually. So the purpose of writing this step means when we are having large number of machines in the industry, and you have a limited manpower. So limited manpower means they cannot. They remain. You say they remain on the shop floor to work daily, because generally you have observed either the industry is running 24/7, or industry is running only in general shift from 8 to 5 or 8 to 6. So when it is a 24/7 and all the machines are running 24/7, then you have less times to repair. Only you take it out, the unserviceable component or the equipment, you take it out, putting a new one, and then it will go to the repair shop, repair station. So when it will go to the repair station, then there also a maintenance crew must be there, and many times they have to take the advice of the people, those who are operating these machines. Okay. So that is the meaning of, you say, document both short and which one will be repaired when. How they will be repaired means how quickly they will be restored back, returned back to the shop floor. Okay. The maintenance problems which is observed in the industry are inspection frequencies. How quickly you inspect? Because daily, because the when we say 24/7, it is operating. So how quickly we do depth of inspection, overall intervals, whether to do repair or wait till breakdown, replacement tools for components, replacement tools for equipment with technology changes, whether or not equipment modification be made, reliability consideration, maintenance crew size, composition of machines in a workshop, spare provision rules, and sequence rules for job requiring some form of maintenance efforts. So reliability centered maintenance, I am skipping. The maintenance policies may be corrective maintenance, preventive maintenance, sequential preventive maintenance. This I am speaking, skipping. This is also the industrial statement we give: maximize availability and enhance capability of machine, tool, equipment, plant, and service through technology upgradation, employing latest maintenance techniques. So guidelines principles are A, B, C, D: accident, breakdown, complaints, defect, and the objective is to make a zero defect or zero, say, non-functioning system. Okay, which we call radar approach. Which also I am skipping because of the time factors. The Relia soft we are using nowadays for measuring the various reliability functions of the equipment. So, these are the various features of the Relia software. Other reliability software which are in place, you say in practice: Wibble, Alta, Block Scheme, RGA, MPC3, and Lambda Predict, QTMS. Okay, so these are some of more. So these are all the things which I want to convey to all of you. Now you are free to ask questions related to. Okay.
Any query is there? Sir, one question is there. He is asking that can the reliability studies of a product be IoT enabled?
Can the reliability of the product?
Reliability studies.
Yes.
Of a product.
Yes.
To be IoT enabled.
To be
IoT, Internet of Things.
Yes. As we have mentioned earlier, that is IoT devices. Where nowadays it is easy, more easy, because every equipment we have has a IoT device. So if the performance also the performance of the equipment is also one feature in the IoT device. That is, for example, we say unnecessary sound, vibration, or the deviation from its operation. If it is there, that also maybe if we say in IoT device we add a feature, that feature also, which will observe the reliability or the performance of the equipment or the component, various component. For example, I already mentioned you that is in automobile, when you say on the panel you get an alert. You get an alert that there is some problem in the engine. There is some problem on a particular, say, carburetor, whatever may be. So some alert is there, some red signal is there. So that is definitely nowadays IoT based devices are there. So you say the performance can you say the alert will be there. There will be an alert definitely, and you can found that some problem may arise on a particular equipment, and the action can be initiated immediately. Okay. Yes, definitely.
Okay.
Any more?
Any query? Anyone? No one. So thank you, sir, for having such a wonderful talk on reliability and maintenance, and I am very thankful that you have given us your precious time, and very thankful to you, sir.
Okay.
Okay, sir.
Should I close?
Yes, sir. Yes, sir.
Okay.
Sure.
Thank you. Thank you to all of the audience. They have listened patiently. Okay. Thank to all. Okay. Thank you.
Thank you, sir. Thank you. Thank you. So, dear participants, we will start the new session after a short period of time, after 5 minutes, and we are trying to connect Dr. Mohit for starting the next session. So please wait, have patience for 2 or 3 minutes.
I think Dr. Mohit is with us. So, Dr. Mohit, I am audible?
Yes, sir.
Okay. So, dear participant, we are going to start a new session on cloud computing, which is an essential part of the Industry 4.0. We have Dr. Mohit Kumar with us. He has done his PhD from IIT Roorkee. Presently, he is working in NIT Jalandhar and affiliated to the Department of Information Technology. So, I forwarded this session to Dr. Mohit Kumar. So, sir, you can start, sir.
Okay, thank you, sir. 1 minute.
There is a present now. You have to share your screen, sir.
Yes, sir. The screen is visible?
Yes, sir. Yes, sir. Fine.
Okay, thank you. Good morning to all. Today we will discuss about the basic concept of the cloud computing, how the cloud is beneficial not for a technical person, but also for all the type of the person, how it provide the service, how a common man can use the services of the cloud, whatever the services. Yes, sir.
Have you started?
Yes, sir.
Yes, sir. I have started it.
Acha. Okay.
Sir is giving the talk, sir.
Okay.
Sorry for the interruptions. Thank you.
Okay, thank you, sir. So, how a common person or a technical person can take the services from the cloud? Services may be any type. It may be computer oriented. It may be storage oriented. It may be database oriented. So, there are the various type of the services provided by the cloud. So, we'll discuss about the services and the deployment model, research challenges, and the limitation of cloud computing, and when we integrate cloud with IoT, what type of challenges we are facing. So we'll discuss one by one. So basically, cloud is provide the services to the user over the internet on the basis of the pay-per usage. Basically, it provides the services as a resources. Resources may be your hardware or software. Cloud computing is basically the on-demand delivery of computing as a service where you pay only the services that you use. Whatever the service you use, it means user have to pay only for the services. There is no extra charge needed to pay by the user. So cloud computing is on-demand delivery of computing as a service where you pay only the service that user use. So this is basically the best scenario or analogy where a common person can understand the services of the cloud. So in the traditional time, we take the water from the well or river, but in the current scenario, we got the services of the water. In the traditional time, we use the lighting with the help of the candle or kerosene oil. It means lamp. But today, we get the electricity, and whatever the electricity we use, we have to pay bill for that. In the same scenario, in the traditional time, suppose I want to perform a computational task, I have to purchase all the things, infrastructure, software, and all things. But in the modern time, using the services of the cloud, you can take the service from the cloud, and there is no need to buy the infrastructure. So this is basically the advantage. Whatever the service you need, you just take the service from the cloud and pay for that. There is no need to buy the infrastructure by the user. So why we need the cloud services? So it is forecast that actually there are a number of the IoT devices and the other devices increasing day by day, and these devices producing the data day by day. So how to store and how to process those data? So to process those data, we need the service of the cloud. So as per the prediction, 23 trillion gigabyte of data will be generated and will be need to process by the cloud data center. Increasing capacity means buying more server and the infrastructures. Lead time for new capacity could be up to the 2 or 3 years. Suppose you buy an infrastructure, and after some time, 2, 3 or 4 years, that infrastructure may not updated, and suppose there are some software not working in that particular infrastructure. So user will change the infrastructure. But in case of the cloud services, there is no need to buy and change the infrastructure. Just use the service of the cloud. So how the service is provided by the cloud computing? It is basically based upon the virtualization technology. So in a virtualization technology, basically the hypervisor provides the virtualization where we can run multiple virtual machines over a single physical host, and each virtual machine works as an independent or individual system. So what is the advantage of this virtualization technology? The advantage is that you can run multiple applications simultaneously without interrupting one application to the other application. So allow a single physical machine to run many independent virtual machines that increase basically the utilization of your resources. The process of virtualization manage and provision the system resources, including your processor, memory, storage, and network resources. You can create the multiple virtual machines based upon the configuration of your physical host. You can create the heterogeneous virtual machine. It means there is no need, need to create all the virtual machine in the homogeneous manner. You can create the heterogeneous manner. It means a VM can have the configuration 2 GB RAM and i3, i5, 2 GB RAM and the core, 2 core, 3 core, 4 core. But other virtual machine can have the 1 GB RAM and the 1 core. So you can create the heterogeneous virtual machine over a single physical host. Enable multiple type of OS to run in the isolation of the other OS. Actually, suppose a physical host have the Ubuntu operating system, and you create the 5 virtual machine on that. So all the virtual machine can have the different OS. One can have the Windows, one can have the Linux, one can have the other type of OS. So all the OS, different type of OS can run at a single physical host with the help of the virtualization. Separating application from the underlying infrastructure, yes, you can run the different applications at a single infrastructure. It means at a single host. This is very cost effective and the energy efficient for the user as well as the service provider. So how to provide the services by the virtualization technology? Suppose this is the consumer, this is a user that want to take the service from the cloud. Okay, so the user send a request to the web browser or CLI. So request goes to the service provider, and that provide the service through the virtualization technology. These are the physical host, and with the help of the hypervisor, we can create the, or service provider create the number of the virtual machine over this physical host, this physical infrastructure. So here they are the virtual machines, and you just get the service from this. So type of the hypervisor. So there are the two type of hypervisor. First one is basically we can directly install a hypervisor. Basically, hypervisor is software that create the virtualization. We can directly deploy a hypervisor over a hardware system, It means there is no host operating system available in this system. Okay. So after that, installing the hypervisor, we can deploy the virtual machine over it. This is the bare metal type. And the second one is basically their system, this is the host system, and this is the OS of the test control system, and we install the hypervisor that provide the virtual environment, and after that we create the virtual machine over it. So there are the two type of hypervisor. You can use any type of the hypervisor to create the virtualization. So there are a lot of services provided by the cloud computing. Software as service, platform as service, infrastructure as service, database as service, data mining as service, function as a service. So lot of services provided by the storage as a service. So, but these are the three basic services of the cloud computing. Okay, so we'll discuss one by one. First one is the software as service. In case of the software as service, a user get the service from the cloud, basically public cloud. Okay, so and user just pay for that. There is no need to manage any hardware or software or any your own data by the user. There is no need to manage. The example is user basically use the YouTube, Facebook, Gmail services, and user just pay for the internet charges. There is no need to manage anything by the user. In the case of the platform as services, a service provider, vendors provide a platform where user can deploy their own applications. So in this case, their user need to manage their own data and the application, but there is no need to manage any infrastructure, middleware, or anything else by the user, but just manage your data and applications. Whatever the application that user is going to deploy over the platform. In case of the example is basically Fort.com, Windows Azure. There are a lot of example of the platform as a service. Third one is the infrastructure as service. In this case, you just get the whole infrastructure. Suppose you just get the virtual machine, and user can deploy their own operating system on that particular machine based upon your work or demand, and after that user deploy the application on that. So in this case, user has to manage the your application, your database, but there is no need to manage the infrastructure and the connectivity. So this is the already discussed the software service. You will get the service through the web browser. The platform as service. You will get the your service provider, basically a vendor provide the platform, and user can deploy their applications based upon the requirement. And this is basically the infrastructure as a service. Look at this. This is very important figure. Suppose there is user. In case of the on-premise mode, suppose I am a user and I want to compute some task, or I want to store something for the long period of time. So I purchase the infrastructure for the computation oriented or storage oriented, or to perform or execute any application. So in this case, user has to manage application, data, runtime environment, middleware, OS, virtualization, servers, storage, networking. All the things are managed by the user in case of the on-premises. But when we move to the cloud services, these are the cloud services. So in case of the software service, there is no need to manage by the user. User just pay the internet charges, and there is no need to manage by application, data, runtime environment, virtualization, server, storage. There is no need to manage by the user. In case of the platform as service, user just has to manage application and data because vendors provide the platform where user deploy the applications. So whatever the application you are going to deploy, user has to manage that particular application and their own data. And rest of the thing is managed by the service provider. So runtime environment, middleware, OS, virtualization, so all these things are managed by the service provider. In case of the infrastructure service, user get the whole infrastructure for the computation-oriented service or other services and has to manage the application, data, runtime environment, middleware, and the OS. So these type of things managed by the user because user deploy their own OS based upon the requirement, application requirement of user, and after that, the rest of the things is managed by the service provider. So if we compare the services of the cloud with the on-premises mode, so this is more beneficial and less costly services of the cloud. So now look at the region and the availability zone. It means how we can take the services from the public cloud and how we can use, how we can deploy the private cloud and take the service from the private cloud. So the availability zone is basically a collection of the data centers, and all the data centers should be located in the same building or some distance in a city. Suppose some data center is fail at any region, so other data centers should be available for the backup. So reliability and the availability ensure in this case. And a region is basically consists of the multiple availability zone. So basically the whole world infrastructure we can divide it in the form of the region. When we talk about the AWS, Amazon Web Services, so there are the worldwide 24 regions. India has only one region, Mumbai. So in the worldwide there are the 24 regions. So we can divide the whole geographical location of the world in 24 regions where the AWS providing the services. So why I'm talking about the AWS? Because AWS is basically leading public cloud. Failure of the one availability zone does not impact at the other availability zone. So how to decide that which region the availability zone would be best for the service? How will you decide that where the user should take the services from the cloud? It means which region user take the services. So before discussing this, I want to show you what the availability zone and how the availability zone is available in India or others. So let's look at this. 1 minute. Screen is visible? Hello?
Yes, sir. Yes, sir.
Okay. So okay, this is the whole world, and take the services. These are the availability zone and the regions. So these are the basically representing the region. So where the India, look at. So this is the India. Okay. So look at this. So when we check the India, so yellow represent the region. Okay. So only one region of AWS in India, and there are the 3 availability zone basically. Here you just get the services in India. Okay. And one more thing here, the local zone. Local zone is basically if we compare with the if we take the example, assume that there is the ATM in the banking system. Suppose there is one branch in a city and there are some ATM available. Okay, so ATM provide the some essential service. You can withdraw the money from that. So local zone is same as the ATM. Okay, it provides some limited services to the user. So these are the basically the local zone available here, and this blue represents your the availability zone. If service is not available in the local zone, then service get by the user get the service from the availability zone. Okay. So these are the 3 availability zone in India where user get the services, and the only one region. Okay, and all over the world there are the 24 region and approximately 75 availability zone. Okay. So let's move at the okay. Visible, sir? Hello.
Yes, sir.
Yes,
Okay.
sir.
So how to decide that which region or availability zone would be best for the service or business purpose? Suppose I am a user in India, I have the option to take the service from the AWS, and I can take the service from the Indian region or Asia region or Australian region, American region or Europe region. So there are a lot of options. But can you assume that that the services, whatever service I get from the India, that will be same price or same type of service in the other region? It is not necessary, because the services charge may be different, depend upon the various parameter. Okay, so it is not necessary that the services charge of India will be same for a particular service will be same in the other region also. So what are the factor a user, based upon that factor a user take the service from the AWS or cloud, public cloud basically. So there are some factor. First one is the latency. Suppose I am the Indian user, I want to take the service from the Mumbai region, so I can take the service in the less latency and in the easy way. Because if I take the service from the Europe region, so latency will be more. So transport network will take the more time to send the request and get back the response. In case of the cost, I already discussed, the cost may be different based upon the income tax policy or other policies by the governments. Third one is the energy. Actually, the intermediate device consumes the more energy if I take the services in more geographical region than the near geographical region. It means suppose I am an Indian user, I take the service from the Mumbai region, that take the less energy consumption rather than if I take the energy other country, because the intermediate devices will consume the energy. The availability of the services is also a parameter. Services should be available. Users should check where the maximum service availability. It means which region is more available for the services. It should not be case that a user take the service and due to some natural disaster or some failure and service is not available in that particular region. So user will choose that type of region that provide the always the service, whatever the failure occur. So this is the basic figure, this is the availability zone and the collection of the basically availability zone, the region, and the collection of the data center is basically the thing, the availability zone. So the cloud deployment model. So there are the 4 deployment model of the cloud. First one is the public cloud. Public cloud means any user can get the service from the public cloud. So AWS, Microsoft Azure, Google Cloud. So there are a lot of example of the public cloud. Private cloud is basically a user deploy the private cloud or an organization deploy the private cloud for their own purpose. And the next one is basically the hybrid cloud. Suppose I am a user and I deploy the private cloud in my lab, and I want to compute a workflow applications and that need the more resources. So I can take the service from the public cloud. So that becomes the hybrid cloud. If you have the private cloud and you are taking the services from the public cloud also to compute a large computation problem. Okay. So there are the various types of the workflow available that need the more computation resources. Last one is the community cloud. A community cloud is formed when the several organizations with similar requirements share the common infrastructure. Suppose all the NITs can form a community cloud and can share their some services with each other. Application of the cloud. So it is easy to use the cloud service without installing any specific hardware on their machine. Cloud computing provides number of applications as well as service in low cost rather than buying the infrastructure. So there is no need to buy an infrastructure to the user, and there is no need to maintain the infrastructure by the user. So you just take the service that is less costly than buying the infrastructure. Cloud computing is also useful in the agriculture and the health sector. Yes. So the application of cloud in the agriculture field also, the farmer still do not know how much pesticide and should use for the crops. So you can deploy the smart agriculture applications for the farmer with the help of the cloud. In the health sector, we can use in the health sector, we are using the services of the cloud. We can collect the data from the patient, and that data may be sent to the cloud for the further processing. And any time after the some year or after the 1 year or 10 years, you can get your data from the cloud. So there is no need to store the data or backup the data in the specific your hard drive or any system. So the basic purpose of the cloud is basically to provide the resource for the computation oriented as well as the storage. So what are the challenges in the field of the cloud? So first one is the resource management. So all the problem you heard about the resource allocation, resource brokering, resource discovering, resource mapping, load balancing, resource provisioning, scheduling, all the terms come under the resource management, because you are getting the n type of the heterogeneous request or applications, and you want to schedule or want to compute those the applications at the m type of the heterogeneous virtual machine. So this problem is basically become the NP complete. So how we can schedule those n type of the applications at the m type of the resources become the NP complete problem, and we propose, or lot of the author propose, the various type of the algorithm to solve such type of the problem. Second one is the scalability and the elasticity. Scalability means suppose you are taking the service from the cloud at a particular time, it needs the more resources, so that can get the services that can take the on demand resources. Okay. So last one is the energy consumption. Actually, the data center is increasing day by day due to the services of the various type of the services of the cloud, but the utilization of the data center is very low, and these data centers basically consume lot of energy. As per the survey, there is only 20 to 30% utilization of the resources of the data center. So in the ideal case, suppose a system in the ideal case that consume approximately more than the 50% energy. So most of the data center in the ideal case, and they are consuming the energy. So we should focus to optimize the energy in the field of the cloud rather than creating or deploying the new data center. So we should focus at the resource management in a effective and efficient manner. So apart from this, there are the various challenges also exist in the field of the cloud. One is the security. That is also a important security challenges in the field of the cloud, and the other challenges also exist. So when we talk about the resource management, so we can divide into two parts. First one is the resource provisioning, and second one is the resource scheduling. Resource provisioning, basically we detect the resource, we find the optimal resource for the services, and after that finding the resources, then deploy the application on that particular resources. So all these terms, the resource detection and the selection come under the provisioning, and the resource mapping, brokering, allocation, monitoring, load balancing. These all type of terms come under the scheduling. So we'll discuss one by one. So what is the resource provisioning? Resource provisioning is basically at the time of the SLA, service level agreement. Okay, what type of the services user need? So on the basis of that particular service and the budget of the budget of the user, on the basis of budget and services, a service provider allocate the resources to the user. It means suppose the user has a budget, suppose the $100, and that take the services from the cloud, and the constraint of the user that the application should be processed within the 1 hour, and no application should be rejected. It means the deadline is constant for that. So whatever the requirement or demand of the user, on the basis of that particular demand, the service provider provide the service to the user. When a cloud service provider accepts the request for the resource, it creates the appropriate number of the virtual machines and allocate them to the user as per their demand. So how we provide the resource provisioning? So there are the 3 plans for the resource provisioning. We will discuss pros and cons of each plan. So there are the 3 plans for the service provisioning: on demand, advanced reservation, and the spot instances. Okay, so we'll discuss one by one. So in case of the advanced reservation, it is a long-term plan that allows customer to preserve the resources. Suppose the user needs the service of the cloud for the 1 to 5 years. Suppose I want to host my application, or I want to host my website, and for the 5 years, so I can take the services from the cloud for the storage service and database service from the cloud for the long term. It means 1 to 5 years. So this type of the provisioning plan is basically for the long term plan. But the issue in this, the advantage of this plan is basically it provides the resources in the lower cost to the user. But the drawback is that it is difficult to predict the demand of the user at the runtime, and there is the possibility of the over provisioning and the under provisioning. So the major challenge is the under provisioning and the over provisioning problem. Suppose what the under provisioning and the over provisioning, suppose the user needs some resources and the service provider allocated the more resources. That's the over provisioning. Suppose the user needs the resources, X resources, and the service provider providing the less than the X resources to the user. That is the case of the under provisioning. So these are the basic challenges in case of the advanced reservation. So how to solve these challenges? So next one in the on-demand provisioning. In this case, user get the service on the basis of the hour basis. Suppose I need the service at this time, I can take the service 1 hour, 2 hours from the cloud. So it means there is no need to take the service from the long-term plan. It means 1 year, 2 year. This plan is basically middle plan. You just take the service for a particular time period, and the hourly basis: 1 hour, 2 hour, 3 hour, 10 hours. This type. So this is the intermediate plan where you just get the services. But this plan basically overcome the issue of the over provisioning and the under provisioning. But the main drawback of this plan is that it provides the resources more costly than the advanced reservation. Last one, the spot instance. So this is a bidding type approach. In this case, hello, any issue, sir? In this case, basically, sometimes user get the resources at a much lower cost than the on-demand or the advanced reservation. So the major cloud service provider, AWS, Google, Azure, provide the such type of the service to the user. So this is the basic advantage of this approach. But what is the drawback of this approach? The drawback is that suppose the user get the resources in lower cost, but the service provider can get back those resources at any time. So service provider do not provide the guarantee that will take the resources after 5 hours, 10 hours or 3 hours, 1 hour. So that can take the resources at any time. Service provider send the message to the user, I need my resource back. Okay, and just take the resource back. So that's the basic disadvantage. Suppose I'm a user, I get the sport instances resources in the lower cost. I'm running my application on that. Okay, so after some time, I get the message, service provider need the resources back. So what happens in this case? What I will do? So that's the basic problem in the sport instances. Okay. So there are some issues I already discussed in case of the sport instances. So these are the open research question. Several researchers are working on this resource provisioning plan. It means a better resource provisioning plan for the user, so that user can get the services from the cloud in less time and the minimum cost. So after the resource provisioning, we move to the scheduling. How to schedule the applications how to schedule or deploy the application at the virtual machine after the provisioning. The scheduling algorithm, basically we can categorize into the 3 categories. One is the heuristic, second one the meta-heuristic, and last one is the hybrid scheme. So the heuristic algorithm basically gives the exact solution of a specific domain of problem in the finite amount of time. But this type of algorithm cannot solve the NP-complete or NP-hard problem. So this scheduling problem is basically NP-complete problem. So this type of the algorithm cannot solve this type of problem. It means scheduling problem cannot solve by the heuristic algorithm, because their solution is moving into the one-dimensional or specific solution provided. Suppose such as the SGF algorithm, round robin algorithm, and FCFS algorithm, SGF algorithm. So there are the various type min-min algorithm. So these are the static algorithm and cannot work in the dynamic environment. And cloud environment is basically dynamic environment. So we need the randomization based algorithm. So the meta-heuristic algorithm are the problem independent and applicable to solve the various domain of problem with the acceptable performance. So this type of the algorithm basically provide the approximate solution of the problem, do not provide the exact solution, but the approximate solution of the problem. So there are the various type of algorithm, meta-heuristic algorithm available in the field of the cloud also. The particle sum optimization, ant colony optimization, spider monkey optimization, honeybee, and the various many more algorithm also available. And researchers are applying this algorithm in the field of the cloud. So when we move to the hybrid algorithm, so hybrid algorithm basically the combination of the heuristic and the meta-heuristic algorithm that is basically used to solve the problem of scheduling in the field of the cloud. Suppose there is some issue in case of the meta-heuristic algorithm, suppose do not providing the proper exploration or exploitation, so we can use the heuristic algorithm to provide anyone, and we combine this heuristic algorithm with the meta-heuristic algorithm for the better solution, and that algorithm basically become the hybrid algorithm. So this basic architecture. So there are a lot of algorithm available. These are some limited algorithm, HEFT, round robin, dynamic round robin, deadline constraint based algorithm, bin packing. All are the heuristic based scheduling algorithm. Min, max, min, FCFS, SGF, priority based scheduling. These are the heuristic algorithm. So meta-heuristic algorithm, ACO, ABC, artificial bee colony, genetic algorithm, PSO, SMO. So various algorithm available. In the field of cloud, there are some hybrid algorithm, ACO plus max min, GA plus best fit plus round robin, PSO plus HEFT. So there are various algorithms available, various hybrid algorithms available in the field of the cloud also. Now, how to provide after scheduling? How to provide the load balancing with the elasticity? So you heard the term of the load balancing. So how to balance the workload? So there are the two ways to balance the workload. First one is, suppose you schedule the application on the virtual machine and start to monitor the virtual machine, and you see that there are some virtual machines are in overloaded or underloaded condition, and you start to manage the workload. How you will manage the workload? Either you migrate the virtual machine or task. Task migration is easy rather than the virtual machine migration. So this is the second approach. This is the first approach of load balancing, but this is very time taking and not a good approach. So it is better to provide the load balancing at the time of the scheduling. When you are providing scheduling, you are deploying the application at the virtual machine. That time you check the available load at particular virtual machine. It means we can provide the application to that particular machine or not. You can check at the time of the scheduling. There is no need to check after the scheduling. So monitoring is done at the time of the scheduling. Now, so we provide the elasticity with the load balancing is also a challenging issue. How we can increase or decrease the virtual machine at the runtime based upon the demand of the user. So how to provide the elasticity? So there are two types of the scalability in the field of the cloud. First one is the horizontal scalability, that is the scale out, and second one is the vertical scalability. Suppose user need some resources at a runtime, so it has the two options: either go for the horizontal scalability and either go for the horizontal scalability or vertical scalability. In case of the vertical scalability, it means suppose I have a system and the system have the 1 core and a 2 GB RAM, suppose. So in case of the vertical scalability, I'm increasing the resource of that particular system. It means I increase the memory 2 GB to the 4 GB, 5, 7 or 8 GB, and I increase the core 1 to the 2, 3, 4, 5, 6, whatever. So this is vertical scalability, but this is not good approach. There are some modern operating systems that do not support such type of the approach in a less latency. But in the second case is the horizontal scalability. That is a much better approach than the vertical scalability, and all the open system basically support such type of the approach. So horizontal scalability, suppose I have the 2 virtual machines and I am running my own application on that, and I need the more resources, so I can take the 2 more or 1 more or 3 or 5 more virtual machines. So it means I am horizontally increasing the virtual machine 1, 2, 3, 4, 5, 6, 7. I'm not increasing the resources of the virtual machine. Now, so if we talk about the scheduling problem, suppose a user, basically the objective of the user is to get the service in minimum time and the minimum budget. But while the other hand, service provider want to get the maximum profit from the service. So suppose that you take the service in the minimum time and minimum cost. So time and cost both are the conflict parameter. And this type of if you want to reduce both simultaneously, so this becomes the multi-objective problem. I cannot reduce both the parameters at the same time. It means one parameter will conflict to the other parameter. Suppose I want to take the service from the Flipkart as a general example. So there are some options available. Suppose the product cost is the $10 and it gives the 2 options. If you need the product in the 1 day, so you pay the $12. If you need the product within the 8 days, 5 to 8 days, then there is no need to pay the extra. So it means if I need the services in the less time, then I have to pay more. So same concept is in the field of the cloud. If user want to compute their applications in minimum time, so it will take the more resources for the service from the cloud. It means user has to pay for more. Time less, but the cost is large. So we should think a conflict. So we should think a compromise solution between time and cost. So the goal of the to reduce the energy consumption and gain the maximum profit in the cloud environment is a challenging problem due to the incompatibility between the workstation and unpredictable user demand. So actually, these data centers basically, as per the survey, consuming the large amount of the electric power, as well as producing the So as per the survey, these data centers consuming a lot of energy. So energy consumption is high. So and utilization of the resources is very low by these data center. So we should focus to increase the resource utilization of these data center rather than increasing the data center. So this way, resource allocation model, how a user can get the service from the cloud. Suppose here I am a user, okay? So I am a user here and I need the service, so I can take the service to the browser. So service request goes to the application or job request handler. Suppose I am using I want to take the service from the public cloud AWS. So at the starting, I have to register at the website. After registering, I will get the email ID or username and the password. So when a user enter the username and password, that is checked here. If this is valid, then it enter for the service request goes for the service. Otherwise, user try again. So suppose that the user is valid and the request goes to the control node. This is basically nothing. That is basically your virtual machine. That basically monitor all the things in the cloud. So the request, which type of request is coming at the cloud, check. The request may be any time. That may be CPU intensive, memory intensive, workflow based applications. So there may be various type of the applications. So there are different queue for the applications. And there's the one more thing, the resource monitoring node. That is basically monitor the status of the virtual machine. So these are the physical resources, and these virtual machines are deployed at these physical resources. So the status of this virtual machine, there may be some virtual machine may be in overloaded, underloaded, or balance mode. So this basically node check the status of the virtual machine and pass to the control node. And these control node have the information all about these virtual machines as well as the upcoming applications that need the services in the form of the resources. So after that, we check that service provider check that what type of services is needed by the user. The service is basically deadline based, priority based, or the number of the resources required by the services. So on the basis of this, the request goes to the mapper. This basically map the request with the available resources. These are the basically available resources. And after mapping that, the scheduler schedule that or deploy that application or request to the virtual machine based upon the scheduling algorithm. The scheduling algorithm may be heuristic, meta-heuristic, or hybrid algorithm, depend upon the service provider. Okay. So second thing is that how the mapper map. So mapper is basically also map based upon the what type of the service or what type of parameter want to optimize by the user. It means you need the service in minimum time, minimum cost, maximum cost, what should be maximum time, what is throughput, energy consumption, availability, reliability. So there are a lot of parameters available here. Okay, on the basis of those parameters, this mapper map the upcoming request with the available resources, and after mapping that send a list to the scheduler, because a request can be mapped with the multiple resources. So which one is the optimal this mapper find out that, and that pass to the scheduler, the list of the resources with the upcoming applications and schedule at the virtual machine. So what are the limitations of the cloud services? There are some limitations. Latency one of the limitations in the cloud. Transport network take the more time. Suppose I need the service of the cloud, healthcare service type. Suppose so the request goes to the cloud, that take the more time. It means transmit network take the more time, more energy, and this is not the secure. Because we know where the data center is available of the cloud. We know the data center of the AWS available in the Mumbai region. So it is easy for the attacker to attack those particular data center. So how to resolve such type of the limitations? How to overcome this problem? So we can overcome this problem with the help of the new technology, that is fog computing. So what is the use of the IoT in the field of the cloud? What are challenges we face when we integrate cloud with the IoT? So we'll discuss one by one. So any smart system who is connected to the internet could be the part of the IoT system. So an IoT device is a piece of hardware with a sensor that transmits data from one place to the another place over the network or internet. IoT device include the wireless sensor, the actuators, softwares, and computing devices. So they can be embedded into the mobile devices, industrial equipments, environment sensor, medical devices, and many more. So what are the limitation of these devices? The limitation basically is storage as well as the computation capability. So these devices have the limited storage as well as the computation capability. So we need the device produce the data, but we need a device or system that can store or process such type of large data. So that's the reason we need the services of the cloud in the field of IoT. When we integrate cloud with IoT, there's some comparison. IoT means the things that place everywhere, but in the cloud, the resources that is available every time and everywhere for the user. In IoT, basically all the things are the real world things, but in cloud services, you just get the service from the virtual resources. It means the virtual machines that is deployed over a physical host. So the limited computation capability of the IoT devices, while the cloud, there is no limitation of there is no limited capability. It means it can provide to the large number of the computational resources as well as the storage resources. The limited storage or no storage capability, but it has the virtual unlimited storage capability. S3 basically software service provides the large number of the storage capability. Internet as a point of convergence, the internet for the service delivery in case of the cloud computing, because you just get the services from the cloud with the help of the internet. So what are the challenges when we integrate the cloud with the IoT? So it need the actually IoT requirement is basically the highly dynamic resources demand it need, but how the cloud actually provides such type of services. So cloud should be a support to the application with the proper elasticity. It means suppose someone needs the more services at the runtime, so it should provide the resources at the runtime. So the real-time needs, that is basically quality of service assurance in the cloud. Here in the IoT, the availability of the applications. Here in case of the cloud reliability is basically challenges, and the security and privacy also challenges. I already discussed that the security and privacy challenges in the field of cloud, because we know the This is basically just type of the centralized system. We know the where data center of the cloud is available, so it is easy a attacker to attack at that particular system. So when we talk about the cloud of things with the fog, when we integrate or when we use the services of the fog computing in the cloud, how to overcome the challenges and limitation of the cloud. So latency, so fog is basically a local node that has a limited capability, or smart devices that have the limited capacity that can process in a less latency. So fog paradigm allows the placement of processing unit closer to the device or sensor. Thus the overall latency can be significantly reduced since the physical distance is shorter. So there is no need to send the data, and no need to send the data to the cloud. All the data or all the tasks or application to the cloud. If the application that is need less amount of the storage or less amount of the processing capability, so you can execute that particular application at the fog node or local node. So what the advantage of this? The advantage is this: you can reduce the latency. So that is basically challenges in the field of the cloud. So we can overcome these challenges by introducing the fog node. Second one is the energy consumption is large in the cloud due to the intermediate devices that consume the energy when packet travel from one point to the other point in a geographical location. So in case of the fog node, you can execute your applications at the local node. So it means the packet or data is not traveling the large distance. It means intermediate devices do not consume so much energy. So we can reduce the energy up to the 40% by introducing the fog node. When we talk about the security concern, all the IoT applications must be secured. So in case of security concern, the fog device is basically in the distributed environment. So it is difficult for an attacker to identify that which fog node have contained the data. So it is difficult to identify that which fog node contains that data, important data. So it is difficult for an attacker to identify that. So it is more secure than the cloud. So this is architecture. Basically, these are the IoT layer, the devices where they can produce the data, and this is basically fog layer. So we check that which type of the application or data we can process here. I'm not saying that there is no need of cloud. We need the cloud, but where we need the service of the cloud. So we should think about this. If the request or application need the less amount of the processing capability and the storage, so we can use the services of the fog computing. If request needed the more computation oriented service and the more storage, so we can send the request to the cloud for the services. So this is basically intermediate node type fog node that provide a limited capability to provide the services to the applications. There are some limitations and drawback of the fog node also. Due to its heterogeneity, fog node cannot guarantee the resources from a particular fog node will be same as the all fog node. So all are in the heterogeneous manner. So there is no need of guarantee that all the fog node provide the same type of the services to the user. The same reliability in the fog node demand much more effort regarding complexity, cost than in cloud system. This is the more complex system in the fog node. And one more thing, suppose that some node, that the security issue, there is some node, one or more than one node is compromised, the whole system may be compromised in case of the fog. If a single node lose the connectivity with the network, even if its hardware is fully functioning, the whole system may be compromised in the case of the fog. So there are some limitation or drawback of the fog, but overall we can say that if we need the services in the less latency, less energy and the more secure manner rather than the cloud, to a small application. so we can use the services of the fog. Otherwise, we go to the cloud. Thanks. Any question?
Dear participant, if you have any question regarding the session, you can or write on the chat box.
This is Balagopalakrishnan. Hello.
Yes, yes, sir.
You can
Sir, what you meant as a fog, is it what is the IoT on this one? What is
Sir, actually, fog is your smart devices. That may be your router, that may be your gateway, that may be your mobile device. So that has a limited capability. So you can process the limited capability, you can process the application that need a limited capability or storage, either storage or computation. So your mobile device can be work as the fog node. So, hello, yes, sir.
is it safeguard measure to secure the IoT devices from the threats and malicious this one, or it is
Sir,
different?
actually, I will tell you, nothing is safe in this world. So there are some limitation of cloud as well as the limitation of the fog. I already discussed there are some insecurity issue in fog also available. So
Is it equivalent to edge computing?
no. Yeah, you can say that some people use the term fog and edge same, but this is not the same. Actually, there are some slightly difference between fog and edge.
Then what is edge, sir? Edge computing means?
Sir, actually, the devices that is directly connected to the IoT devices, that is basically edge, and the devices that is far away, that is connected through the LAN or there's some distances from the IoT devices, that may work as your fog node.
Okay, sir, there is a question that what are the threats of cloud computing? I think he want to ask what are the threats related to cloud computing?
What are the threats? It means what are the security challenges?
Yes, I think.
Sir, there are several challenges available in the field of the cloud still. So first one is the resource management. I already discussed that. How you manage the resources. Suppose you have the heterogeneous resources M type of. So how you basically utilize the resources and provide the services to the user in the better way. Suppose different type of application come to the cloud for the service. So how to deploy that different type of heterogeneous type of resources to the cloud, so that the resource utilization should be maximum and the user get the service in the minimum time and minimum budget, and the service provider can get the maximum benefit. So how you provide this type of thing? So there are several algorithms available, scheduling, provisioning available, but need the more research in this field. This is the one, and second one is basically to provide the proper way the elasticity. It means user can scale out and scale in the application at a runtime. So elasticity should be provided in the proper way in the field of cloud. And the third one is your security. Security also an issue in the field of cloud. And the next one is the latency. Suppose the healthcare type of application that need the services in the less latency, so you should not go to the cloud. You can use the fog node. And the next one is basically your energy consumption is a big issue in the field of the cloud. We are deploying the data center day by day, but the utilization of the resource is not proper, and these data center consume the huge amount of the energy. So that are region, that are basically region, or that are the basically the challenges in the field of the cloud. There are many more challenges also exist, but these are the basic challenges in the field of the cloud.
So the next question is, what is the difference between AWS and SQL, and which is used in IoT?
Sir, actually AWS is a public cloud. Just go 1 minute, sir. Actually, I think I did not stop the sharing. Okay, sir. This is the AWS. Just come to the AWS. Okay, sir. just see the hands-on experience. Okay. Visible, sir?
Yes, sir. Yes, sir.
Okay. Sir, okay. So this is the AWS basically, that is basically public cloud. Anyone can take the service from the public cloud. Okay, sir? So if I want to take the service from the public cloud, okay, so I go to sign in. Okay. So when I go to sign in, I have the two options, root user or IAM user. So I just discuss the root user. So suppose you are the first time user, so you have to go to the create the new AWS account. When you go for the create the AWS account, okay, that need the information, your credit card or debit card. But don't worry, to verify your account is valid, it deducts only 2 rupees. Okay, 2 rupees on after the 1 week, that refund your money. Okay, so suppose I already have the account. Okay, so I am going to here. Okay, just take the how to take the service from the cloud. Okay, so this is basically your AWS. I just log in. Okay, so after login, you just check where are you. So I am taking the service from the Mumbai region. Just check. You can also change. You can take the service from California. You can service from the all the region, 24 region available in the AWS. Okay, but I am in Indian. I am taking service from the Mumbai region. Okay, I can change the any region. Okay, suppose I need the virtual machine, so I go for the computation oriented purpose. So I go to the EC2, Elastic Compute Cloud. So look at this. Okay, so launch the instances. So after launching the instances, you have the option. So there are so many number of the images of the OS available. So there are some are the free, some are the costly. Okay, check at that. This is a free tier. This is a free tier. It means this is the free of cost. Okay, free tier. Some are the free and some are not free. Okay, so you can choose anyone. Okay, suppose I choose the Ubuntu 18 point something. Okay, I choose this. Let's check that. So this is only the T2 micro VM is free, and the AWS basically provides the 720 hour in a month freely. Okay, but be careful about that. If you are using the virtual machine, if you are deploying the virtual machine in AWS, and you after deploying the virtual machine for the 720 hour, and you are thinking that this is free, this is not free. This computers oriented is free, but it takes the charges for the storage. Only for just check. This provide the virtual. This provide the CPU 1. This provide the memory to the virtual machine 1 GB. This is the free. If I use the other virtual machines, I take the service for the other virtual machine. It is basically chargeable. Okay. After that, I will go to the next one, and this okay. There no need to change it. This okay. So here, this is the storage charge. This is the storage charge. So AWS will take the charges for this. So next tag, you can add the tag name, VM. Okay. Now this is the security. I just allow the SSH through SSH TCP. You can add the rule available here. So there are so many. Which type of the traffic you want to allow. So there are lot of options available to you. Okay, so you can allow any type of the traffic. You can enter here the IP address also. Okay, which type of traffic you want to allow. And I will go to the launch. Okay, so here after launch, if I go to launch, I need the either I create the public key cryptography. So if I go to the create the key pair. In this, why need the key pair? That key pair is needed for the authentication, your secure authentication. Okay, I already create the key pair. Okay, and you can give the name of that test. I give the name of the test. Okay. You can download the key pair. Okay, the key pair downloaded. Be careful about this, and this is needed at the time of the when you run the virtual machine. Okay, now look at. These are virtual machines. It will take some time, approximate 30 to 60 seconds. Here you can check until what type of IP address is allocated to the virtual machine. This is the IP address that is allocated to the virtual machine, IPv4 address, what is DNS, and all the information about this virtual machine is available here. Okay, which type of image is available. So this is available here. Okay, so now the virtual machine is a running condition. Okay, so if you want to connect it, so there are some option to connect this, either the SSH or PuTTY. So you can connect it. Now, important thing is that when we go to the if you stop the virtual machine, suppose you stop the virtual machine after using this service of this. So be careful about that. The AWS will charge for the 8 GB storage. It will not charge for the computation one core and the 1 GB RAM, but it will charge for the 8 GB storage. So always after completing your task, always terminate the virtual machine. So we can take the service in this way. From the cloud, we can create the virtual machine. We can use the triple S3 service. It means storage as a service available. So lot of services available here. I go to the EC2 dashboard. Okay. So these are services. So these are the S3 storage service. Suppose you want to store something, you can choose this type of service. IoT core. So all the type of the services available here. The CloudWatch is basically used for the monitor the data or virtual machines. So there are various types of services available in AWS. You can take any type of the service or directly use. Only just pay for the charges. So what the question? Hello?
Sir.
Sir, yes.
He's asking the difference between AWS and SQL.
Sir, AWS is basically public cloud. You can take the service just I show you. And the SQL is basically database as a service from the cloud. If you go to the AWS and type the database, so you have the 5 to 7 option of the database. You can choose any type of the database from there. So SQL is also option available in the AWS.
Yes.
Is anyone?
There is a question that, sir, any best book for mechanical student, easy language? Actually, sir, there is a lot of participants from the mechanical or industrial background.
Okay.
They are interested to learn about this cloud computing from the basics. Can you suggest any?
Yes. Actually, language is basically, if you are talking about the which one is the best, C++, Python, Java, or R. Actually, language depends upon your practice. How much practice you are doing, how much program you are making in that particular language. So I think if you are using the cloud and you want to learn about the cloud, so you go for the Java, because there are several simulators available. In the Java Cloud Sim is a simulator. You can perform your operation, you can deploy your application and check your algorithm and application in the Cloud Sim. So that is basically Java based.
Sir, there is one question that any company can define the cloud computing resources according to their need, or they have to take it on lease from service providers?
Any company that define
the cloud computing resources according to their need.
Okay, actually the resources that I am using, EC2, S3, CloudWatch, these are the resources of the cloud. EC2, what is the EC2? EC2 is a virtual machine. So there are a lot of virtual machines available. These are the resources of the cloud. Suppose I want to compute something. This is my laptop and this has a 4 GB RAM, suppose, okay? but I want to compute some workflow application, and that need the more RAM and more processing capability. So I can take the service from the cloud, AWS cloud basically, and whatever the service, it means suppose I take the service for the 5 hour, and I use the 5 virtual machine. So the cost is also available of the virtual machine in the AWS. So which type of the VM you are going to use, you have to pay for that.
Okay, sir. Last question is
One more thing, so sorry sir to disturb you.
Yes.
You should go to the AWS. That is basically leading public cloud. So there no need to go for the Google Cloud and the Microsoft Azure. So go for the AWS.
Okay, sir. Okay, sir. There is one question that how can we merge data in
How can I?
how can we merge data in hybrid cloud?
No, actually, hybrid cloud is basically just suppose I'm an NIT Jalandhar. I deploy the private cloud in my own lab. Suppose for the research purpose or academic purpose. Okay. But at a particular time, I want to compute a problem that need the more resources, and that resources is not available in my private cloud. It means private cloud is resources limited. Suppose the administrator suppose the system provide me the 4 workstation, and I combine all the 4 workstation and for me or deploy a private cloud. But I need the more resources at a particular time. So what I will do? So I can take the service from the public cloud. Data will be in my system. I'm not sending the data to the public cloud, but I'm taking the resources to that particular cloud.
Okay, sir. I think there is no. Sir has already answered about hybrid cloud. So I think, sir, there is no question.
Sir, one
Thank
more
you.
question. Sir,
Yes.
I have one question. Sir,
Yes.
currently I have the cloud services. I engage the cloud services for all my storage and other purpose. Later stage, if I want to go with my own server and my storage, can I able to transfer all that cloud storage, the data to my own storage? That can be allowable. Data portability. Is it possible to transfer from cloud storage to my own storage? So.
Yes, you can. You can actually suppose you stored some data in the cloud and you need your data, so you can take your data.
For that,
Sir,
if any conditions will be laid by the cloud service provider,
Sir,
or
sir, one small thing. All of the general people, all of the not even related to the computer science, all other branches use the service of the cloud using the storage service Dropbox. I think all are using the all use the Dropbox. So Dropbox is basically some storage providing by the cloud to you.
Yes, sir. I think.
So Dropbox is storage as a service, no?
Yes, sir. So I think all the questions has been answered. So thank you, sir, for a very insightful session. And we from Industrial and Production Engineering Department is very thankful to you for taking your time and giving such a very simple and lucid way this complicated topic of cloud computing. I thank you again.
Sir, okay, thank you, sir. Thank you.
Thank you, sir.
Okay, thank you. Can I listen?
Yeah.
Okay, thank you, sir.
Thank you. Dear participant, we will join again at 2:30. Take your lunch and join us again. Till then, thank you.
फिर बाहर करके अंदर करके कोई जरूरत नहीं है। ठीक है, ठीक है अविरल, ठीक है अविरल, ओके।
Hello, sir. Ravi Shankar, sir. Hello, Professor Ravi. Are you there? Hello, Professor Ravi. Are you there?
यस यस यस, माय स्क्रीन इज ऑन। फुल स्क्रीन में है कि क्या है? अरे मेरे तो फुल स्क्रीन
So, dear participants, we have joined by Dr. Mamila Ravishankar from IIT Tirupati. Before I'm handing over to Dr. Ravishankar, I want to share some brief about his achievements in academic as well as research career. So currently, Dr. Ravishankar is an associate professor in the Department of Mechanical Engineering, IIT Tirupati. Before this, he has actually working as an assistant professor in the Institute of Indian Technology, Guwahati. He did his PhD from IIT Kanpur. Now his current area of interest mainly on micro nano manufacturing, sustainable manufacturing, precision 3D printing, online monitoring, biomanufacturing, coating, tribology, and rheology. His lab also involves in the development of lab scale innovations to commercial manufacturing products. So he has published over 50 journals in internationally reputed journals, 80 international conferences. He has 6 patents to his name. He has edited 2 books and 10 book chapters. Presently, his lab possesses various fundings from BARC, DSC, DRDL, BIP, SERB, IIT Guwahati, IIT Tirupati, of about 30 million rupees as a PI and 600 million rupees as a co-PI. Till now, he has guided 5 PhD students and 8 PhD students are currently working under him. Currently, he is a reviewer of many reputed journals published in Elsevier, ACS, Springer, Wiley, in the Science Sage. He is currently an editorial member in IMAP, Journal of Manufacturing and Journal of Manufacturing, and also guest editor for International Journal of Precision Technology. So I think he is also working in the project that is funded by Government of India that is related to Industry 1.0. So in this session, we will going to share some of his experiences of the project also. So I request Dr. Ravishankar to kindly do this. Sir, you can start.
Yeah. So thank you, Avril Mishra. So Dr. Aviral was one of our juniors. So we have a very good collaboration. Thank you for giving me the opportunity to showcase my research work. Am I audible, I guess?
Yes.
Yes, sir, you are audible, sir.
Yes. So thank you, NIT Jalandhar, for giving me the opportunity, especially Aviral Mishra and his team. Okay. So what I am going to talk about today is applications of Industry 4.0. So directly or indirectly, what one must know as a manufacturing engineer is whenever you want to enter into a smart manufacturing or Industry 4.0, being a manufacturing person, what I feel is that I should know that particular process in and out, the process physics and how the process mechanism and other things. So what I would like to tell you is, initially, I just want to take one particular process where I am comfortable, that is abrasive flow finishing process, how we are converting that particular machine into a smart machine, how we are embedding the Industry 4.0 technologies in it. Okay, so that is what I want to go, because many of the people nowadays talks about Industry 4.0 and other things, but still there is a big doubt among the conventional manufacturing guys that what is the difference between a conventional and smart machine. I have a lathe machine. I want to convert into a smart lathe machine. So how do we convert? Similarly, so many people know it already. So how we are going to convert our patents actually this particular technology has a patent for us, and how we are converting this particular technology into a smart technology. So it is not 100% smart, but we tried our best to make it smart, and still some of the things are going on. So whenever no, this is a third generation IIT. Many people don't know about IIT Tirupati. So those people who don't know about IIT Tirupati comes under the third generation. What you can see here is a yellow one. So third generation IITs. We are came as a third generation along with IIT Palakkad, IIT Goa, IIT Dharwad, IIT Bhilai, and IIT Jammu. These are the 6 IITs that are given along with the existing first generation and second generation IITs, and we are doing fairly good compared to our brothers and other who are the co-generators. And so regarding this, what are the milestones and other things? It is started in year 2014, and we have a 10 years plan up to 2024. Okay, so these are some of the things. And one of the beauty about IIT Tirupati is, compared to where I worked in the previous institutions, is we have one additional program for PG, that is MS by research, like IIT Madras, because our mentors are IIT Madras. So we have BTech, we have MTech, we have PhD. Apart from this, we have another one course called MS by research, Master in Science by Research. So it is applicable for all the mechanical guys or all the engineering streams also. So those people who are interested to join exclusively for the masters to do research, they can opt MS by research. Okay, that facility is there at IIT Tirupati. It is like a 3 years program. It is like a mini PhD, that before going to write a mains examination, prelims examination, right? No, like that. Okay. So regarding the departments, we have 4 core departments initially, that is civil, computer science, electrical, and mechanical. Later, we added one of the departments, that is chemical engineering department. And we are supposed to add 2 departments. One is material science and engineering, and another is School of Design. However, because of some issues or practical issues because of this pandemic and other things, so we are unable to add, and we are going to add this particular sessions or the particular departments in upcoming years. So we have sciences and humanities. Yes, excuse me. Okay, so we have humanities and social sciences, chemistry, physics, and mathematics. These are the sciences groups that we have at IIT Tirupati. Okay, so coming to my resume, because already Aviral has already told, we have more than 3 crores funding as a PI, and more than 60 crores of as a co-PI we have, and our group is doing fairly good. So yesterday only we received from Indian Patent Office saying that our patent has been accepted, and due course of time our patent documents, the granting of patent will receive. So from IIT Kanpur, we are very thankful to IIT Kanpur, where they have sent yesterday saying that congratulations that your patent has been approved. Okay, it since is long been, so we have submitted that patent in 2013. It is a granted now. So those people who are interested to submit the patent and other things, you should know that it takes a long time. So if you have good work and other things, you can please go ahead and submit. So it may take minimum 4 to 5 years of in that one. Okay, so regarding the research group, let me introduce about my research group. As Professor Aviral was saying, that 5 graduated and 1 submitted, so that was not added. So 5 already graduated from our lab. So 1 is submitted, and another 10 are in line. So almost all 16 students as per the PhD is concerned, and masters who more than 25 are processed already. So BTech and other things. So our research group comprises many areas in ultra precision manufacturing. We don't call it as other things. So we confine ourselves to advanced manufacturing or ultra precision manufacturing. So we add some of the things and we find some of the applications to it. So however, our major core will be in the area of advanced manufacturing, or in particularly advanced machining process. So the first and foremost group that I handle is micro machining and nano finishing group, where it is bread and butter for me from the day one of my research, real research from the PhD days. Then sustainability in manufacturing or sustainable manufacturing group. So I did my master's in sustainable manufacturing. So I started again. So one of the student has graduated PhD and currently working as a postdoctoral fellow at IIT Bombay. So after joining IIT Tirupati, so we initiated after getting a enormous knowledge and other things, because we were working on since 2 years on how to start and where to start and what to do about additive manufacturing. So we started additive manufacturing. We have wire arc additive manufacturing, we have powder bed, we have direct metal deposition, polymers, and many advanced materials also we are working. And smart manufacturing is the latest group that we have got, and we are recently getting some funding in the smart manufacturing. So another one area where we are working is bio nanomaterials and manufacturing group. So 3 core groups we have already established and we have published, that is micro machining and nano finishing group, sustainable manufacturing group, and bio nanomaterials and manufacturing group. Okay, so I just give you the glimpse. So about micro fabrication or micro manufacturing group, what we do is micro machining of micro holes, micro slots, and doing polishing and characterization and other things for many applications like automobile applications, nuclear applications, microfluidic MEMS applications, and other things. These are the areas that normally we work, and wherever our application suits, we just find and expand our wings. The second one, what normally we do is sustainable manufacturing group. Sustainable manufacturing, we work on sustainable cutting fluids. We work on sustainable cutting tools also. Nowadays, we started how to make a good cutting tools for different applications like defense applications and other things. We are customizing our cutting tools also. So whatever this particular slide shows you is the emissions. You can see here the emissions are coming up on the during the machining operation. Whenever a simple material like mild steel is machined by your HSS, so normally the temperature ranges from 500 degrees to 750 or 800 degrees. At the time itself, these mineral oil based cutting fluids fall, and they will give emissions. These emissions fall on the face, fall on the hands, fall on the head, and you inhale. These are the lot of problems like chlorinated, contacted dermatitis, hair follicles, cancer, asthma, bronchitis, many problems it creates. So what we do is to overcome all these things, we try to do a dry machining, cutting tool, advanced cutting tools for the dry machining. At the same time, we also go by a biodegradable cutting fluids. These are the 2 areas that we are currently working, and we have already worked also. Regarding the sustainable manufacturing, we also do where it is purity is concerned. So for example, if I want to do a micro nozzle or a micro mixture, basically people do by micro EDM process, micro laser beam micro machining process, or electrochemical process and other things. All these processes majorly changes the microstructure, changes the metallurgical aspects, and if at all I want to use for biomedical application and other things, it may not be, because you need the purity of the metal there. For that purpose, what we did is there is one concept called biomicro machining, which is nothing but micro machining using bioorganisms. So what we do is acidothioBacillus peroxidans are the columns, cellular columns, bacterial columns that we get. So these are to be cultured first. Then after culturing, so simultaneously what you have to do is you have to do the photolithography where you have to do the coating on unwanted region and expose the wanted region. Then once it is done, you just keep aside. Then what you have to do is you have to get this isolated bacillus fluorescence columns from reliable sources of IC in Indian government or any other sectors. Then you have to culture the medium. Then you have to populate it. Once you populate it, and then you have to put this particular workpiece material wherever it is exposed. Okay. So for the machining applications, then you will get after a few days. That the only drawback, particularly this one, is that it is a time-consuming process. But the purity that you get is better, and you like a advanced manufacturing process. You don't require a hard cutting tool to machine a soft material. So you can do a soft cutting tool also can do a hard material like EDM process. This also works. This is one of the good things that we have. We also ventured into the composite materials. So particularly when particular student want to do exclusively into bulletproof materials, because Major Sanjeev Kumar Sahu is the army major. He joined under our research groups, and now he is a lieutenant colonel and working at the Pakistan border. So India-Pakistan border. So he is working. He completed his masters and doing his PhD. Now we have done on a ballistic impact and many things, because he is army guy, and what we need is to develop the materials. Then you just go and test in the field. Okay, so this type of materials where we have used some of the nano materials inside, and we just compare with the commercially available what the Indian Army is getting. And okay, so currently this particular project has been completed, and we are venturing into a big project for other sophisticated applications in this area. So as I said, additive manufacturing currently is a very costly process, because if at all you want to purchase any brand like SLM or EOS or Renisha, any particular brand, these starts minimum, if it's all depend on the bed size. If you are going for 280 by 280 by 300 or something, the type of bed, normally it will cost you minimum of 3 crores rupees. So you should be, initial investment is so high, you should be wise enough where you need to use. For example, here if you see the satellite, this particular antenna component, this one is previously manufactured in a different segments, and there are joined. Okay, the weight is 1.6 kgs. The same thing can be developed by this topological optimized, and the same thing is reduced to 940 grams. This type of applications is well and good. If you are using for building a flat surface, if you are using for building a cylindrical surface and other things, that may not be a viable solution. Okay, so you should be. You can see the second application where the 3D printing can be used. If you see the hydraulic manifold normally uses for the rig applications, underground drilling rig applications, where this is a block, solid block that you are seeing is a drawing. So this is not a problem. Making a casting of this one, then you do drills is not a problem. But the basic problem comes is whenever you see a internal structure of this particular thing, these are joining at different angles. Okay, that is a major challenge to manufacture this particular block. So that is the biggest challenge. So see, this particular thing cost you approximately 1.5 months to 2 months of your valuable time. Second thing, it may not be a costly affair whenever you drill the straight holes. Whenever you drill joining perpendicularly and other things, you may not achieve the perpendicularly. So maintaining the functionality, so 3D printing technology is arrived. So what you need required is you understand that what is required, and you can manufacture it by the additive manufacturing. then this is more competitive and less material waste and whatnot. It is 90% of the weight reduction. It can be, see, initially it is 14.6 kgs. Now it is to 1.3 kgs. So obviously it's a good move. So what I want to tell the people at this particular junction is that use additive manufacturing for the good things. Okay, so we also venture into direct metal deposition using our vessels and cladding systems and many more, repairing and other things also. We some of the machines are yet to be arrived, some of the machines are arrived already, some of the additive manufacturing systems are there, and we are going in a big way for the additive manufacturing because it's a good future and other things. Okay. So one of the additive manufacturing that normally we already completed is coatings. So bioceramic coatings on a bioinert materials like titanium alloys and other things. What we did is we just coat the surfaces, then we change the parameters of coating and we observe the different micro surfaces. Okay, that is needle like of porous surface, spherical type of porous surface and solid surfaces. These are more required because you need to do the cell culture, because you are talking about biomedical applications. Whenever you want to put inside the organism like a rat model, rabbit model or anything, what you require is your cells has to be adhered. If it is not adhered properly, the big problem is that it cannot hold the cells. That's why always you require a texture that is porous in nature on the surface. If it is porous in nature, then only the cells will adhere. Why? You cannot build your home without any basement. So you need to build the basement, then you have to continue it. That's why for these textures, whatever the texture that you are seeing or the porous structures what you are seeing is the basement for the cells so that it can grow its roots inside so that it can firmly adhere. That is the most important, and what you can see here is how this is adhering. Normally there will be a big challenge whenever you want to grow MG63 cells, osteoblast cells, for example osteoblast cells. Okay, so osteoblast cells means bone cells. If at all you want to grow, the cell size itself is 30 microns. Okay, so you have to decide your parameters such a way that you required porous structure is to be precise and to be as per your requirement. If my cell size is this much, what will be my porous size? Whether I want 2 microns, whether I want 15 microns, whether I want 4 microns. This optimization is another biggest study. Those people who want to do, they can do it, and we are also doing it. So what we do is, once we do the coat on a titanium surface, then first and foremost study that anybody do is biocompatibility test, whether the material that I developed or whether the material that I coated on the surface is biocompatible or not. So that is what in vitro test, one of the in vitro tests that you do. So what do? You just make a simulated body fluid. Standard available literature is for making SBF, that is simulated body fluids. So you make a simulated body fluid and just put for few days. Every day you just take out and observe the apatite layer formation. So if you can able to see apatite layer formation, if you see the second row, expanded version, you can see not only the coating, that is a black one, so you can see a white structure is forming on top of it, and that is nothing but apatite layer. Apatite layer means that material is biocompatible. It is comprises of your bone composition. Okay, apatite, hydroxyapatite is your coating material. Whatever the coat that is generated is apatite. So chemically, the composition wise, it shows a bone chemical nature, apatite layer. That's what. So later what we found is, we have taken a titanium alloy where heat dissipation is very poor. Second thing is it is a ductile material, and whenever you are coating a bioceramic on top of it, the basic problem is adhesion problem. So to overcome the adhesion problem, again, the common thing that normally a manufacturing guy can do is texturing. So again, we did the texturing. The texturing is done with the 0 offset, 25% offset, 50% offset, 10% offset, different offsets we have to do. Once you do the different offsets, what we have to do is you have to measure the contact angle. So whether I am getting a super hydrophobic surface, super hydrophilic surface, hydrophobic surface or hydrophilic surface, you have to. So now different textures, now you are measuring contact angle, and what you have to choose. You have to choose is because here the coating has to stay for a long time. That means that you should go for super hydrophilic surface. Okay. Then you do for super hydrophilic surface where your SBF droplet can stay for in an expanded position. So this is how the microstructure look like, and for the 25% overlap and 50% overlap. So once you get good surface as per your requirement, so first it has to be properly textured. Second, it has to understand the microstructure mechanically as well as metallurgically and using a goniometer. Then you can go back and you can do the simulated body fluid study. Now previously we did without texturing. Now we are doing with texturing. Here also what we did is we have done a functionally graded material, because functionally graded material is required because whenever you do the texturing on the titanium try to oxidize. Even though you are doing at inert atmospheric conditions, there is a less chance, but there is a less chance means there is some chance is there. Some oxide film slightly formation is there. And now what we have to do is we have to coat it 75% titanium oxide and 25% hydroxyapatite, 50-50, 75. So gradually you have to decrease the titanium oxide, so that what will happen, whenever you do the laser texturing, you are getting a titanium oxide small micron percentage oxide film is there. Then now you are adding 75% of titanium oxide with bioceramic 25. Next layer will be 50-50. Next layer will be 75% of hydroxyapatite and 25% of this one. Then the final layer will be 100%. So my adhesion will be very much good. So once you understand the tribological properties of that one, anyhow you have already understood for the 100% of hydroxyapatite, it is biocompatible. Still, you can do the re-evaluation like this. What you can do is you can just again you use the simulated body fluid for the in vitro conditions, and you can see here the background, whatever you are seeing, the black one is a hydroxyapatite, and the flowery like structures whatever you're seeing is apatite layer. That means that this particular material is biocompatible material. Then once you are proved to be biocompatible material, there is another test also. Okay, so whenever you do this one, you continuously monitor the pH value of the solution, SBF. So it always try to increase. If it is increasing, that means that it is a biocompatible material. These are the two verification studies one can do. Okay, so once you are happy about this one, then you can directly go to cell culture analysis. So where cell culture analysis, what you can do is just you get the MG63 cells or any osteoblast cells, because your application of the coating is for the orthopedic applications like bone applications. So you need to get the bone cells, and then you just culture these, and you can understand under the fluorescence microscope how the MG63 cells are adhering. So there are how it is growing, how it is forming, with how much density it is forming. These are the studies that one can do. So whatever you are seeing, the green ones is the filaments, okay, actin filament, and whatever the red ones is the nucleus. So you can understand how many cells per unit area is there. That shows the density, how better the cells are growing. Moreover, why you have to do this particular study is not only the growth of required cells. If we have impurities, the biggest problem is there. Apart from your cells, there will be a chance of some other cells also will be grown. For example, you are a farmer ओके आप किसान हैं, आप क्या करेंगे? आई थिंक देयर इज सम डिस्टर्बेंस.
No, sir.
Somebody, okay, so somebody got the disturbance. Okay, so आप suppose मान लीजिए कि आप किसान हैं, so you are a farmer, so whenever you try to put a groundnut field, what will happen? Groundnut अकेला उगती नहीं है, उसके साथ घास भी आता है साइड में. That is the problem. So whenever you do the MG63 cells, what is your required cells? If there is a impurities and other things are there, then there will be a problem of other unwanted cells growth that we have to understand. Toxicology, toxic studies and other things. So those things are very big things. So I'm not going to in deep of that one. Okay, so this is the one. So now the bottom line of the story here is additive manufacturing we have quoted. So this is the research, but how it is going to help the common man? That is what we are here to help the common man. Okay, so what is the thing? Initially, if you are not going to coat, what do the people do? They will put the titanium implant or titanium plate. For example, there is a bone fracture, you need to put a titanium plate or SS316L plate. So what is the biggest challenge here? So titanium plate or SS316L plate, if you are going to put and tighten with the screws, the body orthopedic side as well as the muscle side, both sides are there, interfacing it is there. So both of those things treat that particular material as a foreign material, and there is a heavy chance that that particular material may be create some problems. Okay, that's why you need to coat the similar composition that has a bone. That's why we have chosen hydroxyapatite or bioglass or something where chemical composition is same. Whenever you coat on top of it, what will happen? The bone thinks that some bone type of material is there, so cell proliferation will take place. So the drawback of this particular study, okay, whatever you have seen is good. Now coating is done, and the drawback of this study is whenever you do the operation, for example, the operation cost is 1 lakh rupee, and you are putting inside a human, after 1 year or 2 years, you have to take out. So secondary operation is required because titanium is a non-biodegradable material. So what is required? Secondary operation will cost approximately 60% of the original cost. That means that आप suppose 1 लाख रुपए लगाया है, तो बाद में आपको 60,000 फिर से लगाना पड़ेगा कि उसको हटाने के लिए. So that means that the total expenditure a common man putting is 1.6 lakhs rupees. So this tends to us to think about biodegradable materials where your secondary operation can be avoided. If you can put some material inside, so if it can be degradable, secondary operation is not required. Okay, so that's where we have entered into the another area that is called biodegradable polymers or the nanocomposites, where we fabricate PLA nanohydroxyapatite based bio-internal fixations, so bone plates and bone screws and other things. Okay, so we made the stands. Stands are you can have a commonly stands because you can put into the 3D printer, and these are the customized for our 3D printers and other thing. You can make membranes whenever there is a brain hemorrhage or something. Just whenever the skull is opened, then you have to put some of this membrane, and before it is going to stitch the skin, top skin is stitch between. You have to put all these things. These are biodegradable. So once you make a recipe that is polylactic acid, so polylactic acid made in 2 varieties in our laboratory. One variety is manufacturing a monomer, that is lactic acid, then do the polymerization, and the second variety is getting a commercial PLA, then you do the purification. These are the 2 processes that normally we do, and anyhow we have already used for nanohydroxyapatite. So you can make a cortical screws, cancellous screws, staples, plates, Stedman pins, and different applications you can normally use for your bone application. The advantage here is that you can avoid the secondary operation. But what is the drawback? Again, जिंदगी वहां पे रुकती नहीं है. जब रेडियो था वहीं पे रुक जाता तो अभी तक हम लोग रेडियो में घुसते थे, प्लाज्मा टीवी कभी नहीं आता. So here, what is the drawback? The drawback is 1 lakh rupee. That how to reduce still 1 lakh rupee? The 1 lakh rupee में आपका मेजर कास्ट जाता है नॉट फॉर द इम्प्लांट मटेरियल. फॉर एग्जांपल, इफ आई वांट टू परचेज दिस पर्टिकुलर screw or a plate, normally in the market it may cost you like 2000, 3000 or maximum 5000 rupees. But लेकिन आप डॉक्टर को कितना पे कर रहे हैं? 1 लाख रुपए पे कर रहे हैं. तो if is the cost of surgery, it is the cost of your staying inside the hospital for long durations for the rehabilitation and other things. Now my question is that can we avoid the surgery itself? So that was the question mark. So can we avoid the surgery? So that, however, we found one of the solutions that I just want to say, because whenever any person got accident, so bone is a brittle material and it has a very complex micro features of joining. One male part, another one is female part. So if at all I want to make it, people say that 3D printing, but 3D printing won't works for nano features and other things, because these XY motions you cannot control in sub nano levels or Armstrong levels. Those machines, I don't know whether existing, or if it is existing, it will cost you enormously very high cost. Okay, so 3D printing cannot do. So what the solution is? But as in English language, but is very dangerous, because if you say I don't want to give any wrong example. I want that, but I need this thing like that. This is a very dangerous word. So what is the thing is, this particular technology is not suitable for heavy load applications like legs and other things. These are applicable for low load applications where hairline fractures are there, where fingers are partially up to hand and other things. Okay. What is the technology? Is thermosensitive injectable scaffolds. At room temperature, what is the thing is that it is a liquid. So you have to understand the rheology and the science of flow and deformation. So once you just take to the operation theater or under the X-ray videography, you can see this one. And once you develop the recipe, what does the recipe do? It is a liquid, it can penetrate inside. And this injection, you are not opening it by cutting, just you are under the observation of the X-ray, whether the particular material is reaching to nook and corner or not, that you are observing by injecting from multiple directions. Once it reaches to nooks and corners, even though excess is there, it won't happen. It won't be a problem because your polymer is a biodegradable polymer, your ceramic is a biodegradable ceramic and other things. It won't cause much problems. Once it reaches to each and nook and corner, after some time, it happens is because of the body's temperature 37, it becomes a porous structure. Basically, the composition is a hydrogel. Hydro means water. So water molecules, it goes off. So anyhow, your body also contains 73% of water. How do you know 73%? If you see that advertisement of Aquaguard, Madhuri Dixit will tell, there will be a boy will be standing and boy will become 73% water. Okay. So from there, I understood that our body has 73% of water. Okay. So these are hydrogels. Hydro goes off and there will be a porous solid structure. This solid structure will be a converse shape to the negative part, also to the positive part, and it will adhere both the positives and negatives. Bone is an autotomy. The cell culture will take place from the both sides. When the cell culture will take place from the both sides, what will happen is it collapses and mixes with the bone. So since it is also a chemical composition of the bone, there won't be much. That's why the healing will take place. Okay. So now we have the hydrogels knowledge, we have liquids, rheology and other things, we have the cell culture knowledge. Now I say thermosensitive injectable scaffold, that is bioinks, what other people call it as. We have the knowledge of this one, we have a cell culture, then we are venturing into a 3D biomanufacturing. So one of the group of what you can see here is a biomanufacturing, that is called a bio 3D printing. So once you have a gels where I can populate my cells, if at all I want to manufacture a year, so the stem cells of corresponding stem cells, I have to grow inside this particular matrix. Okay, so once I do this particular technology, then I can do the printing and I can do the post processing for that one. So this is what we are expanding our wings into the 3D bio printing technologies. This is about particularly about my laboratory, what we are doing. Some of the things I am unable to tell you because of some of the patent problems, some of the commercial industries problems and other things. So whatever I can able to tell you, I have already told. Now we are moving into how to make a smart nano finishing process. Okay. So before to understand a smart machine, it will be a normal machine. So first I will explain the physics of the normal machine. Once you understand the machine, then you can convert into a smart machine. Okay. For that purpose, you have to understand how when you can understand what is the applications or what is the motivation of your study is most important. So some of the people, whenever I went for presentation and other thing, oh, finishing, क्या है यार घिसते हैं, एक ले लो सरफेस है जस्ट घिसो, ये नहीं है, इतना इजी नहीं है घिसना, for point to point curvature change हो जाता है, so you cannot do that particular thing. This is a unpolished knee implant, this is a polished knee implant. So if you take the surface roughness of both, then this will have unpolished one will have very rough. That means that assuming that a triangular surface is your surface roughness. So surface roughness, so inward triangle may, what will happen is your body fluid stays, then it will be a problem. At the same time, you need for a knee implant, relative motion is one of the biggest things. So you need to do polishing so that the body fluid flow freely on top of it, and the mating surface, that is meniscus or cartilage, or if you are changing the knee implant along with the cartilage, that is nothing but artificial cartilage, the wear and tear properties should be much stringent enough. Okay, so these has to be understood. So how to finish some of the complex surfaces? Knee implant is one of the complex surfaces. These are some of the complex dyes, because dye industry is one of the biggest industry. Okay, this has to be properly polished. Okay, these are some of the bio implants to be polished properly, like knee implant, cardiovascular stents, hip implant. Under the hip implant, you don't require complete polishing like what you are seeing in this one. You don't require these things. You require only acetabular head and acetabular socket, or acetabular cup. Some people call it as a cup and other things. These are required. Okay. So can it be done by grinding process? Grinding, honing, and abrasive sheet based things, these cannot be done because these are all our solid tools. So solid tools can do a simple geometries like flat surface, cylindrical surface, and other surfaces. But point to point changing complex or freeform surfaces, if at all you want to polish, it is a complicated job. So what we did is we found, I cannot say found, we worked on a liquid based or semi-solid based cutting fluids. You can see here high viscous medium, medium viscous medium, and low viscous medium, where you have a polymer and you have abrasive particles. These are mixed using a rheological additives and other things. Okay, so this particular thing is used. But what is the current scenario? The current scenario, if at all I want to finish, what is how the Indian industry is doing? Indian industry is doing by mass finishing process. So for example, you take some of the mass finishing process like centrifugal disc tumbling or centrifugal barrel tumbling, which is come under the category of vibratory ball finishing. So you just put abrasive particles and you put implants. There are two drawbacks of this one. One, those implants or those components which are near to the central axis may not be that much polished as compared to those particular components which are away from the central line axis. Second thing, these implants or these are the components will collide each other. So there will be a deformation process. When there are two components are hitting each other multiple times, there may be a damage too. If not damage, there will be a deformation, minor deformations and other things. Whenever it goes to the quality control for a customer and other things, what will happen? There is a heavy chance that these particular things are rejected. So for that, to overcome this, people came up with some of the technologies like belt grinding and drag finishing process. In the drag finishing, whatever you are seeing here, so your component is held by one of these things, and you are going to rotate that particular thing, and your abrasive particles also, you can depend on your requirement, you can also rotate. So there won't be a inter component hitting can be avoided. At the same time, all the components will rotate about their uniformly and same time. So some of the things can be overcome. These are some of the things. We also have this drag finishing at our laboratories. So these are mass finishing applications where 30 components or 50 components depend on your size. 50 components or something you can do in one go. But this particularly is not a nano finishing process. This is a global spectrum. So if at all I want to fabricate or polish up to the nanoscale, then you have to go for advanced finishing technologies. One of those technologies where we have converted into smart is abrasive flow finishing technology. See, this abrasive flow finishing technology, this is a machine. Whatever you are seeing a machine, this machine is converted into a smart one. So how this is converted into a smart one, we will see in the upcoming slides. There are three main elements of this one. One is a machine structure itself. Second one is a fixture. You can see here, I have a cylindrical red workpiece is there. On top of it, two flanges are my toolings. Why the tooling has to undergo two functions. One is it has to allow the finishing medium to flow across the surface, and it tries to guide to the nook and corner of the surface. These are the two functions, and the most important in this abrasive flow finishing process is medium. Why? So the medium is the cutting tool, which is a soft cutting tool. You cannot add the diamond particles to your water because sedimentation problem will come. So it is a complicated technology where polymer networks are functionalized and abrasive particles are functionalized so that they are held by the polymer networks at desired locations. That is the most important thing. So that is a completely different history, which is, I'm not going to talk much about that one because of the spot. And the most important thing is this particular medium, 2 kgs is around 5 to 6 lakhs rupees. What the rate I'm telling is about 5 to 10 years back. I don't know what is the current cost of this one. So this is too expensive. If I want to do 10 experiments, I cannot put on my consumables 5 lakhs rupees. So this is one of the challenging ones. So we have patented it. As I said, our patent has been accepted by the Indian government, and now we are willing to provide to the commercial industries also. Okay, there are multiple varieties of medium. One is a low viscous medium and high viscous medium and other things. Okay, so if at all I want to do only polishing, I can go for high viscous. If at all I want to do polishing, come radiusing and other things. Okay, so now the technologies lies slightly here. What is the technology is why you want to choose a viscoelastic material. This particular slide, almost all it took me minimum 2 years during my PhD, but it is a one simple mechanism. Okay, so we played with different no unknown rheological things and polymers and other things. Now we are getting some roughness, but which polymers are going to give better roughness? That is a challenge, because whenever you want to patent it and other things, commercialize it and other. So the technology I'm not telling you completely, just I'm telling you the principle, the viscoelastic material. So visco and elastic is there. If I'm not taking about abrasive particles, I'm taking a viscoelastic element. I am applying a shear force. One element I'm taking, I'm applying a shear force. So shear force, if I am applying, there will be a motion of this medium along the direction of shear force and perpendicular to shear force. Visco and elastic. For example, if I take honey into my hand and I just throw in one direction, the honey try to flow in the same direction because it is a viscous medium. Same thing whenever you have a eraser, which is an elastic. I'm not saying it is a purely elastic material, but it has some viscous component in it. So you just press it by your thumb. What will happen? It tries to move perpendicular to your application load. That is the technology. Where if my elastic component is moving in this radial direction, my viscous component is moving along the shear force direction. Now, if I take an abrasive particle and if I can hold the polymer networks as per my requirement, what will happen? I am going to put an axial pressure, extrusion pressure in this axial force direction. So axial force will be there, axial velocity will be there, radial force will be there, radial velocity. Radial velocity will be much less. So what will happen? I can impinge, I can penetrate this particular abrasive particle into the region and I can force with axial force and velocity so that I can neatly remove. This is the basic mechanism of viscoelastic medium. So you can do for viscoplastic and many things. The basic problem here is this particular medium flows like a fluid. That means that whenever you make a spherical ball and put on a flat surface, what will happen is the bottom surface after 2-3 minutes, it will become very flat. That means that it is deforming with atmospheric pressures, self-deformable material. If it is deforming with the atmospheric pressures itself, if I am putting extrusion pressure or external pressure, what will happen? It will deform as per my requirement. That is what I want it. So it will behave like an elastic ball. Whenever I make a spherical ball and hit on the ground, what will happen? It jumps like a tennis ball. So behaves like a plastic piece. Whenever I take this particular sphere, try to expand with my both hands, what will happen? If I slowly do it, it will expand like a bubble gum. If I do it very fast, what will happen? It will break like a plastic piece. So the flow characteristics, the deformation characteristics are completely unique. It is very difficult to understand. That's why we did a rheological study, that science of flow and deformation. So this particular study is divided into two. One is a steady state rheology, another one is a dynamic rheology. Okay, so commercial available rheometers are available. So whatever the test, whatever you are seeing is an Anton-Par. There is a TA instruments, other instruments also available. So Anton-Par 301 is the old one. So 302 is the new versions. So you can do, you can see here the schematic where your red one is a bottom plate and the top one is a rotating plate. In between you have a sample. So you can see here the bottom. So this is a fixed plate and you have a rotating plate, in between you have a sample. Okay. So we have a sophisticated tool masters with a diamond cone pattern and other things for proper fixing and other things. So whenever the shear rate increases, that means that my top plate start rotating at faster rates. So what will happen is whenever I am increasing the shear rate, my shear stress is increasing. If you just consider any one graph, all the graphs follow approximately same trend, just to follow one graph. What is shear rate increasing? When the shear rate start increasing, the polymer molecular chains are climbing on each other. So what will happen? Unity of the polymer chains will come and it try to obstruct the motion of top plate. That has a torque sensor inside and it converts into shear stress as well as up and viscosity and other things. So beyond certain limit, anybody has its own strength. What will happen? Beyond certain shear rates, what will happen? It starts breaking and align in the direction of the rotation. So that is what happened here. So you can see there is a decline in the second region. Okay. Now you can see the plasticizer. Plasticizer is one of the rheological additives which plays a major role. And plasticizer is a low molecular weight material. Whenever you take a polymer normally considered to be the high molecular weight material. Whenever low molecular weight material will blend with the high molecular weight material, what will happen? You can see here, this is the polymer molecular chains. Interpolymer molecular distance is very less, so adhesion, the cohesion will be very strong. Whenever you are adding these plasticizer molecules, the low molecular weight materials are added to the high molecular weight polymer chains. The advantage here is these polymer molecular chains are kicked apart by penetration of low molecular weight materials. That means low molecular weight materials will embed in between polymer molecular chains and the distance will increase. Okay, so still if you are increasing, what will happen? These polymer molecular chains, distance between two polymer molecular chains will increase. That means that interpolymer molecular force of attraction will decrease. Okay, that means what I mean to say is F1 is much greater than F3. That's why you see here, if you see cross-sectional wise along the y-axis, 7.5 is your green and pink is your 12.5. So it is a decrement because of this. Okay. So, but this is a basic flow studies. Your basic flow studies is required because you need to understand flow and deformation. Now, you have to understand the viscous component and elastic component because it is a viscoelastic material. For that, creep recovery test has to be done. Creep recovery test means you have to give certain load, you have to observe the strain with respect to time. Okay, so now the $1 million question is that how much load I have to give, whether I have to give 1 Newton, whether I have to give 10 Newton, whether I have to do 1000 Newtons. That is the biggest question. For that purpose, what you have to do is you have to do the dynamic rheology testing. So you can see the small graph at the bottom, which is nothing but stress sweep test or shear stress sweep test. What we are going to do here is you are changing the shear stress and observing the storage modulus. Storage modulus means how much energy it is absorbing before breakage and other things. As you increase the shear stress, there is no change initially in the storage modulus. It is a completely a horizontal curve, and beyond which there is a non-linear. So what will this means? In the initial stages, even though I am changing the shear stress, there is no change in the storage modulus. That means that it is absorbing, but it is not breaking or it is not disturbing. So that means that this particular region is called LVE region or LVE range, that is linear viscoelastic range. That means that my polymer molecular chains are at original strength. So if I can use, that means that if I want to test the viscoelasticity, I want to test at original polymer strength, not the break-in zone. So if I want to use, if I use 3000 Pascal, but I am not going to get a right value. So what I have to do is I have to take such a way that my polymer molecular chains are unbroken or at original strength. That's why we have taken a value of 100 Pascal and we have tested it. Whatever A to B is your viscoelasticity, then after 500 seconds you are releasing. This is a standard test which is called creep recovery test. So A to B is viscoelasticity, B to C is elastic recovery. So now you can understand what is the viscous component, what is the elastic component, because you know viscous and elastic component combinedly, then you also know elastic component. So you can get the viscous component. Once you understand the viscous component and elastic component, what is you are going to get. So that now this is all about the chemical engineering aspects and other things. Now we have to come back to our manufacturing and we have to analyze it. If I am using 35% viscous component, that means that my 65% is elastic component. Elastic component is very high means your indentation will be very strong, or radial component is very high. If the radial component is very high, what will happen? It not only do the shearing, it will also generate its own shearing marks or the peak or the indentation marks. So you have to find some suitable value of viscous component and elastic component so that the nano finishing can be done. Once you do the basic study, you can go for applications, any type of applications, say like nano finishing applications, cylindrical surfaces applications and other things. What later people have done for the knee implant, only thing is that you should have recipe. Once you have wheat flour, you can make chapati, puri, dosa, or समोसा भी बना सकते हैं, है ना। तो आपको क्या है ना, आपको होना चाहिए मीडियम, ओके, एंड करस्पॉन्डिंग tooling, corresponding other things and other things. So this we have done for the knee implants and other complicated components and many components that we have done for micro surfaces and macro surfaces. These are some of the applications that we and our collaborators has done. So then we have, is it not sufficient there because requirements are stringent as per people are concerned. So then we move to a preparation of the medium for the micro holes also. So these are the micro holes. Normally, why you require the finishing of micro holes? Whenever you do a laser beam machining process or electrical discharge micro machining process or something, what you are going to see is the surface is like this. Whenever, if your surface is like this for a fuel injector nozzle, if the surface is like this for any biomedical application, what will happen? Your drug has to be eluted, or your the petrol has to be eluted. Then what will happen? This will create a lot of problems. Okay, so take an example of cardiovascular stents. What will happen if your hole is like this? Okay, so instead of protecting you, this stent, what will happen is it will kill you, because this is a recast layer. Recast layer is a brittle material. At the same time, it is much harder than your artery hardness. So you need to do polishing applications and other things. Okay, so we have patented this technology, and as I said, patent already arrived. This has a unique feature that is called temperature dependent medium, because some of the rheological additives that we use are controlled by the temperature. So today, if you are going to purchase, just it is a marketing slide where if you are purchasing a medium with high or medium viscous, and you can do big surfaces. Later, if at all I want to do micro surfaces or high aspect ratio holes, what you can do is particular machine, our machine has a temperature controlling unit. I will show you our smart machine, how it works. Not completely because of patent issues and other things. I will show you. It has a temperature controlling units on the medium cylinders where you can play with the temperature, and already you have this is not a big standard table that we normally give to the commercial persons. This is one of the rough table to understand the physics. So once you want the viscosity of certain value, so you can fix, because you know X and Y are the data sheets. Now you can bring, or you can put on a smart machine what is the temperature that I want, so that your medium viscosity will reduce. So these are some of the things that we have done. The commercial people have asked us to polish it, but whenever they give, these are the EDM surface. The surface roughness is approximately 14 microns. So initial surface roughness plays a major role for the final. So people ask normally that I want a nano surface finish, but whatever he gives is a big micro surfaces. 14 microns a person gives and asks for 100 nanometers. You cannot do directly a process, so you need to go for multiple processes. That is one of the process you can use is electrochemical polishing and chemical polishing. Then you have to understand what is the layer formed, because whenever you use in an EDM makes your surface very hard, depend on your dielectric fluid. If you are using a petroleum based dielectric fluid, it makes your surface carbides. So normally you should be wise enough. If you need a post processing requirement, normally those people who works in EDM, just I am telling you a suggestion that if you are going for a post processing, then you try to use oxide based fluids like deionized water and other things. Even if you use deionized water in one condition, if you use a petroleum kerosene, for example, in another case, what will happen? In one place you form oxides, another place you form carbides. Carbides are a bit harder than your parent material, but oxides are not. How do you know? It is as simple as if you put a mild steel plate in the rain and put in your home for 1 week, what will happen? Rust will come. Rust is oxide layer. Just you can remove by your nail also rust. That is, oxide layers are smooth enough to remove. So if at all people are looking for post processing, that like finishing, so your pre-processing processes should be equally important. Okay, then we have done for the common materials for micro holes, and then we have done the polishing, and now we recently got another one project for advanced materials from BIRAC for cardiovascular stents applications and other things. We have polished the surfaces on one of the biomaterials. So this is about the surfaces that we have done, and you can clearly see here the finishing marks, how we have removed the recast layer and other things. This is the recast layer, spheroids and other things. So the applications is in two sectors that we have. One is fuel injector nozzle sections. You can see here micro EDM or micro laser. Whenever you do, recast layer is formed and you need to polish it. Otherwise, improper combustion will take place, because whatever the fuel it is ejecting may not be as per the standards. When it is not as per the standards, what will happen? Improper combustion takes place. If whenever improper combustion takes place, what will happen? Lot of smoke will come. So pollution ही pollution है, pollution का festival हो जाएगा. Okay, so you can also do for some other application. These are deburring applications and other things. This is whatever I have shown, because your drug eluting rate, whatever we are doing is not about finishing and other things, but whatever cell culture analysis, as I said, recent project that we got, so we have to do a lot of cell culture analysis, lot of analysis we have to do on micro machining and nano finished drug eluting stents. We have to do cell culture analysis, in vitro, in vivo, blah blah blah. Lot of things are involved in the big project. Okay, so this is about the research that we have done. Now we understood that what all required for my machine. Now how to convert this particular machine to a smart machine. So to convert into a smart machine, what I need a cyber physical systems. Okay, one of the human interfacing is required, so that you did not to do much things. So now I have designed my system. Now I need only this system has to be controlled by some electronics. Okay, that is called as Industry 4.0, which is an automation type of thing. Okay, so these are the, I am not bothering about the medium fixture and other things. Only in this particular slide, I am bothering about this particular machine. So now I have to understand the design, how I designed my system, where is a motion required, and how to automate that motion for the betterment or to overcome labor intensity and other things. These are some of the designs that we have done. I'm not going in deep. We have still more designs. Once we finalize the design, then we have to understand where is the motions are required. First motion I required for medium cylinders. Second motion I required for, if at all I have a offset work pieces and other things, I need to go XY axis. This will move in X axis, this will move in Y axis. So these motions are required. So I need a linear slides and guideways, which are electronically controlled. So you have hallmark systems and other systems. Now you need to design your system, whatever we have as a controller. This is a human interfacing controller. Now at the same time, these motions are controlled by what? These motions are controlled by extrusion machines. Okay, these are controlled by hydraulic power packs. These are the three views of our smart machine. This is the front view, how it look like. So this is the one where we have a Siemens the controlling systems are there, and a lot of electronics goes inside, because some of the things are patented, so which I am not going to discuss much about these things. So these are interfaced. See where it is interfaced. It is interfaced to hydraulic power pack. Okay, this is the some of the setups when it is manufactured. This is the hydraulic power pack that is going to assist my machine. So these are some of the electronics that are PLCs based, smart controller based, and other things are there. Okay, so then you have to design your guideways, then you have to design your things according to the machine that you require. So once you do, then you have to understand the hydraulic circuit. Once you understand the hydraulic circuit, where is the solenoid valves, where is the proportional valve, what is the function of the proportional valve, what is the function of the solenoid valve, how solenoid valve can be automated, and other things. So for that purpose, you have to understand where is the relay. So once you understand the electronic part of the hydraulic power pack, now you can design your system. So human interfacing system is there, where digital input and output, analog input and output, programmable controller you have to design. Proportional valve and hydraulic power pack has to be continuously controlled by servo drives in the XY axis. These are the things, one of the block diagram that how we made a system automated by understanding two things. One is our complete machine, we know because we built it. Second thing is we have purchased commercially the hydraulic power pack, and whenever you are purchasing a hydraulic power pack, we also get the internal structure of it. So that means that whatever the drawing that you have seen. So once you have to understand solenoid valve and other things, then you have to do by human interfacing system and other thing. This is the complete design of our smart machine, and this is a complete fabrication. We have done a fabricated one. So it is at IIT Tirupati. So fortunately, we in the pandemic we received this particular machine, and the most important thing is that's how we made our smart abrasive flow finishing system from a abrasive flow machining system. So just it is in 1996 and 97 the first version of abrasive flow machining, it is called at the time. So abrasive flow finishing system is started in our laboratory at IIT Kanpur. Then in 2005 and 2006, almost we have used the same machine for 7 to 8 years. Then there's a problem because these plates are very, very big, and these plates weighs around 30 kgs to 40 kgs. If at all, Professor Vijay Kumar Gorana was the guy who was working, and Professor Sunilja was the guy who started the process. So this particular thing is not easy to operate because you need multiple people. So then in 2005-06 we have modified based on our calculations and safety factors and other things. Now it can be done by 2 people. Then there is a performance improvement that we want to do. Then we have went to rotational and a lot of other features also. Now the same thing has been modified to a commercial scale. If I want to sell this one, people may not be happy to. So you need to give basic structure. Then you don't want any human person or any operator to wait for there. So just what he has to do, he has to load the workpiece and he has to put whatever the input condition that he want, and let the component will be taken out and other things. So it is a smart and commercial machine that we have developed. So one of the machines is available at CMTI. It is called AFM 150D also. So this is how our patented technology has been given to the CMTI people. They are regularly using this particular machine, and it is giving them a good amount. Okay, that is all about the smart manufacturing setup that we converted from a normal abrasive flow machining process. Okay, what you require is the most important thing is that you should have in and out knowledge of your machine. Once you have that machine, then you can convert you can convert. If you cannot convert, you can collaborate with electronics guys, you can collaborate with computer science guys, and you can modify your system to a smart system. Okay. So regarding other things, so we have, if at all those people who want to go through some of my courses in NPTEL, it is freely available on YouTube. You can just go Introduction to Machining and Machining Fluids is one course. Introduction to Abrasive Machining and Finishing Process is another course. Polymer Assisted Abrasive Finishing Process is third course. There are 3 courses available in YouTube. Those people who want to know about any basics of advanced manufacturing or conventional manufacturing up to certain extent, they can do. Okay. So as Professor Aviral Mishra was telling, I am the guest editor for International Journal of Precision Technology. I am editorial board member for IMechE Journal of Micro Manufacturing. Those people who are working on micro and nano manufacturing, please submit your quality papers, and we are happy if we receive a good quality papers. Okay. So these are all possible because of funding. So we are very thankful for the funding people like IIT Guwahati, where I started with my startup grant of 5 lakhs. Bob Atomic Research Center, we received 23 lakhs around. Then we got a big project about nearly 1 crore, that is about DST project. Then a DRDL project about 75. Then during this course of time, we received a big grant that is about 60 crores from DAY-5, but currently it is called MITI, Ministry of Information Technology, Electronics and Information Technology, about 60 crores on theranostics, therapy plus diagnostics for bio implants and other things. Then we have 2 projects with IIT Kanpur and IISc Bangalore about worth of 6 crores. Then IIT Tirupati, we got again a startup grant. What is, and ACRB is about 45 lakhs, and BIRAC, as I said, we are going to do on biological analysis of drug-eluting stents and other things for this. This is about the funding, and some of the fundings I have not given because accepted projects, but because of the COVID and other things, funding not received by IIT Tirupati. Okay. The second most important is the people who works behind, from the PhD students, master students, bachelor students, and some of the good summer interns. Summer interns has a very good passion. Those people who are interested to come and join and our group for the summer, we are most welcome. So some are very fascinating, and due credit has to be equally given to those summer interns who work intensively. And in fact, we have given authorship in our some of the topmost journals like Cleaner Production, ASME, and there's a Journal of Material Processing Technology, these type of things, because they played a crucial role for in during those 2 months also. So good students, hardworking students, always welcome to our research group. Even though you may not be part of IIT as a student, you can always come during summer and you can approach with your resume. If you are good enough, obviously we give you a chance. Thank you one and all for your kind attention throughout my presentation. If you have any queries, suggestions, you are most welcome. Thank you.
Thank you, sir. If there is any questions, then participant can write it on chat box or directly ask Professor Ravi Shankar.
हाँ, आप पूछ लीजिए, कोई प्रॉब्लम नहीं. So those people who are asking, just introduce yourself and please ask the question. That will be nice, so that
Your sound is not coming, Mr. Nagendra.
I think his mic is not open. Please ask him to open his mic.
Mr. Nagendra, you have to unmute your mic and then you can ask your question.
Hello, sir.
yeah, please, sir.
Hello.
Yes.
Yeah, please tell me, sir.
Yeah, sir. Can you able to listen me, sir?
Yes, sir.
Go on. शेख साहब, आप आगे क्वेश्चन पूछ सकते हैं.
हाँ sir. Sir, actually I was studying mechanical engineering in Madhya Pradesh Institute of Technology and Science, sir. So what is the criteria that to do a research in IIT Tirupati, sir? On which criteria you will be selecting for the students to do a research in mechanical subject?
You are Sheikh Kader Hussain Basha.
Yeah, yes, sir, yes, sir.
So the procedures are clearly defined on the websites. So normally you should have a gate score and you should be a master's student and you should have a decent CPI because there is a cutoff for the CPI. Because even though we say the CPI is minimum criteria is X value, but normally preference because once you receive multiple applications, we have to do some screening. So then internally, normally in Corona time, we have that much cutoff. Otherwise, what will happen now? You have a written test. So once you pass the written test, then you have to undergo the interview. So if you do everything fine, obviously you are one of the candidates to be grabbed by IIT Tirupati. That is a standard protocol. Almost all IITs follow the same protocol.
Sir, as you said that the students have to do masters, but is there any possibility for a bachelor students, sir?
Yes. You can. There are some institutions like IIT Guwahati. You can join directly from BTech to PhD.
Okay, sir. Thank you.
There is a provision in all IITs, but only thing is that in that circumstances you have to spend 1 extra year in PhD. If you are a master's, assume that you are going to, normally it will be 4 years. If you are going to do from BTech, your stipend will be given another 1 extra year since you have not done master's. So your coursework will be slightly higher. That is what
Thank you for your valuable information.
So you are the nearby only, no? So you are nearby Tirupati only. You can come down at any time. There is no problem.
Okay, sir. But right now I was doing bachelor's in mechanical engineering, sir. Finally, mechanical engineering.
Yeah. So Madanapalli is just a 1.5 hour, 2 hours.
Yeah, yes, sir. Yeah, yes.
Yeah, you can come down. You can come down and you can discuss that.
Okay, sure, sir. I will come, sir. Thank you for valuable information, sir.
Yeah, please.
Thank you, Ravi sir. I think there is no question regarding this session. So, thank you, Ravi sir, for taking your busy schedule and taking some time to share your research experiences. We are very thankful. Now, participant, we will going to close the STC. So.
I am in class. I am in an online class. Can you call me after 15 minutes? Yeah, I am leaving now. It's fine.
Sorry, sir. Actually, there is some power problem.
Yeah, please.
So actually, there is a power problem. So internet has disconnected. So from mobile, I am again joining. Sorry for the interruption.
Okay.
All the parts.
Anyhow, it's completed. No, my part is completed.
Yes, sir. So for 2 minutes, you can be there because.
Please. I am there. I am waiting.
Statement for the STC.
Yeah, please.
On behalf of the organizing committee, I want to thank our Honorable Director, Professor L.K. Basti, for providing us the opportunity to conduct this STC. Organizing team also thankful to the coordinator TQ3 for funding this STC. We are also thankful for all the speakers, included Professor Ravi Shankar, for sharing their insight and as well find their time from the busy schedule I am also thankful to Dr. Rajiv Trehan, HOD of Industrial and Production Engineering Department, as well as the Chief Convener of STC for providing guidance and support. We are also thankful to Professor R.K. Garg, Professor Anis Sachdeva, Dr. Ravi Pratap Singh, Dr. Mohit Tyagi, Dr. Dilbag Panchal, and all other departmental colleagues for their continuous support throughout the STC and whenever required. We are also thankful to all the participants for sincerely and actively participating in this STC. Thank you all. Thanks a lot. Yes, sir. Ravi, sir?
Yeah.
Thank you. So, thanks a lot, sir. We will being in contact with you for further talks on some other STCs.
So thank you. Aviral was one of our good friend, in fact. So Aviral, you're always welcome, and I wish you all the best for your future endeavors that you just started at NIT Jalandhar. So lot of good people are there. So you just grow as much as possible. And thank you, one and all.
Thank you, sir.
NIT
Thank you for the compliments, sir.
So Aviral Mishra and other colleagues and NIT Jalandhar, thank you, one and all. Thank you.
Thank you, sir. Thank you.
Yeah,
Thank you,
I'm
sir.
leaving now.
Yes, sir. Sure, sir.
Yeah. Okay, please.
Sure,
Thank you.
Thank you, participant. Your certificate will be distributed based on attendance, and after that they will be mailed in your email as filled in the Google form during the registration. Okay. For any query, you can post the email. Thank you all for participating, and hoping all the participants will going to join in some coming STCs.
Thank you, sir.
Thank you all.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir. Thank you very much, sir. Thank you, sir. Okay, thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah. Ruban. Yeah.
Button? Button होगा?